This is a lot to type. If you want, you can just copy the code that I posted in the comments down below. Just copy and paste it and you'll have all of this. Or if you want, you can pause the video and type it. I don't care. So now that you have your questions and your options, we're ready to begin. So the first thing that we'll do within our program is to call the new game function to begin a new game. So after we have our questions and options created, let's create a new game by calling the new game function. Now, when we run this program, we'll generate our dictionary of questions and our 2D list of different options for each question, and then we will call the new game function to begin a new game. So let's head to the new game function and fill in everything within our new game function. So at the top, let's declare a few things. Let's say we have a list named guesses, and guesses will be an empty list for now. I will declare a variable called correct guesses, set it equal to 0 because we haven't guessed anything yet, and we will set a current question number and set this equal to 1 to represent the first question. Okay, now we need to display all of the questions within our dictionary of questions, and we can use a for loop for that. So for key in questions, I'm going to print my key. And let's just test this. Okay, yeah, here's all my questions. I think what I'll do is actually print something to separate each question. Let's say one of these lines. I think it would look better with them. Okay, I'll print this line, and then we'll move on to a question. Alright, now after rerunning this, we have each question, and I added just a line break between each of these to make it look kind of fancy. Now, I need to display all of the different options for each question, and we can do that with a nested for loop. So if I were to write for I in options, print I, let me show you what happens. Now, with the way this for loop is written now, it's going to display all of the different options available to us for the entire quiz game. What I would like instead is to display only the first list for the first question, and then the second list for the second question, and follow that pattern. So we're going to change our for loop around. For I in options, and we'll set an index for options. The index is going to be our question number minus 1. Now remember what I said in previous videos where different collections, including lists, tuples, etc., the first element in a collection has an index of 0 because computers always start with 0. Then the next element would therefore have an index of 1, then 2, 3, then you follow that pattern. We're using this question number variable as some sort of counter, and since we initially set this to 1, I'm just going to subtract 1 so that we effectively receive 0 as the index. And now we just need to increment our question number after each iteration. So let's do that. I will add that to the end here after we finish displaying all of the options. Let's increment question number by 1 by typing question num plus equals 1. And if I were to run this currently, we'll display all of the different options for each question. Who created Python? Here's all of the associated options. What year was Python created? Python is attributed to which comedy group? And lastly, is the Earth round? Now it's time for some user input, so I'm going to create a variable called guess. And make sure you don't put it within your inner for loop, it should be within the outer for loop. Guess equals input, and I'll create a prompt. Enter A, B, C, or D. Here's something to consider. We would like the user to type in either capital A, B, C, or D. With strings, they're case sensitive. What if the user typed in one of these letters but lowercase? If they're correct, we would still like to give them their point. Why don't we take our guess and make it uppercase? So guess equals guess, and we can make this uppercase using the upper method of strings. At the end of this game, I'm going to compare our guesses to the correct answers. So we have an empty list named guesses, and I'm going to append our current guess that we're working on to our list of guesses. So guesses dot append, and we will append our guess this round. Now that we have our guess and we've appended our guess to our list of guesses, let's check to see if it's the correct answer or not. So we're just about to fill in this check answer function next. So we are going to call this function and pass in a few items as arguments. So let's use the check answer function, and we'll pass in the key for the current question that we're on. So the key is the correct answer. So that would be our questions dot get key. This would be the answer, and we'll also pass in our guess. And we are going to fill in the check answer function, but we need to set up the parameters. We're receiving effectively our answer as well as our guess. So I'm going to name these as answer and guess. And we are going to check to see if our answer is equal to our guess. If answer is equal to guess, let's print something. Print correct. And I think we should give the user a point. We'll have our check answer function return 1 for 1 point. Return 1. Else, if this is not the correct answer, let's print wrong, and we will return 0. They do not get a point. And since this is returning a value, we should assign that. So let's assign the point we may or may not receive to our variable of correct guesses, which is initially set to 0. So we'll type correct guesses plus equals check answer, and check answer will return 1 if we scored a point or 0 if we did not score a point. And make sure you have plus equals, because if you just set this to equals, then we cannot score more than 1 point. It will either be 0 or 1. So we are effectively incrementing our correct guesses by 1 for each point that we score. And now we're going to work on the display score function, and we'll call that at the end after we finish all of our questions that we have. So make sure that you do not write this within the for loop. It should be outside of it, because once we finish iterating through all of our questions, we're going to display a final score. So let's call the display score function, and we'll need to pass in some arguments, our correct guesses, as well as our list of guesses. Okay, let's head to the display score function. So we have, as parameters, correct guesses, as well as guesses. I need to remove this pass. I'm going to add one of these fancy lines in just to separate the questions from the results. And I will print results. And maybe another one of these lines. Okay, so I need to print all of the answers. Answers. And I do not want to end on a new line, so I'm going to set end equal to nothing. And I need to display all of the values within our dictionary, all of the answers. I will do that using a for loop. For I in questions, print questions dot get I, and I do not want to end on a new line, so I'm going to set end equal to nothing effectively. And then I'll print a new line. Okay, let's work on the guesses. I think I'm just going to copy all of this and make some changes. I'll replace answers with guesses. For I in guesses, print I. Okay, let's just be sure that everything's working. We're not calculating a score quite yet. So I'm just going to answer A, then B, C, and D. On second thought, after printing each of these answers and guesses, I'm going to add a space after each of these. So within each of these for loops, at the end, I will add a space. Let me try that again. A, B, C, D. Okay, not too bad. Now let's calculate the final score. And we're still within our display score function. Let's set score equal to correct guesses divided by the length of our questions. And let me add a set of parentheses around here. Then I'm going to multiply our score by 100. And if you don't want a decimal portion, because we'll display a percentage, we can cast this as an int. Okay, that all looks good. And we'll print the final score. Print your score is plus, we need to cast our score to a string because we're using string concatenation, plus I'll add a %sign. Alright, let's try it. I'm intentionally going to get the last question wrong, so we should have a 75% if we have 4 questions. So that would be A, B, C. Is the Earth round? What's Earth? I'm gonna guess D. Answers A, B, C, A. Your guess is A, B, C, D. Your score is 75%. Okay, let's test it, but getting all wrong answers. D, 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 D. Your score is 0%. Congratulations. And we'll test it one more time, but get all the right answers. We just want to be sure that we have 100%. That's A, B, C, A. Your score is 100%. Now, the last thing that you can add is that we can play again if we want, and I have a separate function for that. If you would like to add this option, here's how to do so. Let's remove that pass. Let's set a variable named response equal to some input. Do you want to play again? Let's ask for yes or no. Actually, let me remove that. Okay. And depending on the user's response, it might be lowercase, so let's make it uppercase. Response equals response, and use the upper method. If response is equal to yes, all caps, if response is equal to yes, then return true. Else, we will return false. And that is it for this function. The last thing we need to do is to create a while loop that will continue to ask the player if they want to play again. This will be after we call the new game function. While play again, and remember this will return either true or false, depending on the user's response. While play again, new game, and call the new game function to create a new game for us. If we escape the while loop, that means the user doesn't want to play again, so let's print a message. Such as, bye. Alright, let's test it. I'm going to get all of the correct answers this time. A, B, C, A. Alright, your score is 100%. Do you want to play again? I'm going to type yes. Alright, then we can play again. D, 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 D. Your score is 0%. Do you want to play again? No, I think I mastered this game. Bye. Alright everybody, so that's how you can use Python to create a simple quiz game. I will post all of this code to the comment section down below. But, well, yeah, that's a basic quiz game in Python for you all. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to explain object-oriented programming in Python, so sit back, relax, and enjoy the show. Welcome to today's topic on Python object-oriented programming, also known as POOP, and in today's video we're going to be creating objects. An object is an instance of a class. By using programming, we can create representations of real-life objects. So look around you wherever you're sitting or standing right now. You are surrounded by objects. Next to me I have a phone, a television, some snacks, and I'm talking into a microphone. Point being, we can use programming to mimic real-world objects by assigning a combination of attributes, what an object is or has, and methods, what an object can do. Now, in order to create an object, we'll need to create a class. A class can function as a blueprint that will describe what attributes and methods that our distinct type of object will have. You can either create your class within your main module, or you could create a separate file dedicated solely for your class. Now, to create a class, we would type class and then the name of the object that we would like to create. So today I would like to create some car objects because I like cars. So we would type car. And a common naming convention with class names is that they should be capital. So car is going to have a capital C. And for the time being, we need to type in something. I'll just type in pass as a placeholder. So if you have a small program, it may be better to write your class within your main module. But if your class is fairly large, you may want to consider placing your class within a separate module. So if you were to take that route, we would go to File, New, Python file, and we would name this car, click Python file, and we would declare our class within the separate module. So class, car, and for now, I'll type in pass. Then we just need to import this class. So within our main module, we would type from the name of the module, import the name of the class. From car, import car. Now, objects can have some combination of attributes and methods. Attributes describe what an object is or has. So what are a few attributes that cars might have? They might have a make, so let's create a few variables. For the time being, I'm just going to use none as a placeholder. Cars can have a model, a year, and a color. Now, objects can also have methods. What kinds of methods could cars perform? Perhaps a drive method and a stop method. So let's define those. DEF, let's say drive, and we'll have one argument, self. Self refers to the object that is using this method. Now, what do we want to do when we call this method? Let's say this car is driving. Let's create a stop method as well. DEF, stop, and we will print this car is stopped. We now have all of the different attributes and methods we would like our car objects to have, but there is one more thing that we need. It is a special method called the init method that will construct objects for us. In other programming languages, this is known as the constructor. So we need a special method that will create objects for us. So we need to define this method, def, and the syntax on this is somewhat strange. It is 2 underscores, init. It's short for initialize, 2 underscores again, and then we need at least self as an argument. And then we can actually assign our car objects unique variables. So take all of these attributes that we have, and we're going to place them within this init method. Now we can receive arguments when we create car objects, but we need to pass them in as arguments to our init method. So we need to set up some parameters. Let's say in order to create a car object, we need a make, a model, a year, and a color. Then when we receive these arguments, we can actually assign them to each car's specific attributes. But we need to precede each of these with self. Self is referring to the object that we're currently working on or creating. So self.make, self.model, self.year, and self.color. And then when we assign these, we're going to say self.make equals whatever make that we receive when it's passed in as an argument, self.model equals model, and continue that pattern for year and color. All right, that is all we need for our class car. We have a constructor. We're assigning arguments that we receive to the attributes of our car object, and we also have 2 methods, one for drive and one for stop. Now we can start creating some car objects. So going back to my main file here, to create an object, we need a unique name for it. Let's call this first car just car1 equals the name of the class, car, then a set of parentheses. Now, in order to construct a car object, we need to pass in a matching set of arguments. You can see here that we need to pass in a make, a model, a year, and a color. So what kind of car should we make? Let's say that the make is going to be Chevy. We need a model, perhaps Corvette. A year, 2021 is good. And a color, let's say blue. All right, now let's actually access some of these cars' attributes. And I should probably put this within a print statement. So print car1's make, and this should print Chevy. Then we can do the same thing for model, year, and color. So let's change some of these around. Model, year, and color. Yep, this object is a Chevy Corvette 2021, and the color is blue. And we should have 2 methods as well. So car1, I would like this car to use its drive method. This car is driving, And let's have this car use its stop method. Car1 dot stop. This car is stopped. There's one thing that I should mention real quick because I forgot to mention it earlier. So within our init method, you can see that we need 5 arguments in order to construct a car object: self, make, model, year, and color. But when we pass in our arguments, we're not passing in anything for self. We only have 4 arguments here. That's because with Python, we do not need to pass in self. That's done automatically for us. We're referring to the object that we're dealing with. As you can see with our drive and stop method, we need to pass in self in order to execute our method. But when we call this method, we do not need to do so. So just remember, with Python, with self, we do not need to pass in anything for this argument. That is all. Now, the nice thing about this is that we can reuse this class as a blueprint to create more car objects. We just call that init method that constructor. So this time, let's create a second car called car2. And this will be a different kind of car. What kinds of arguments should we pass in? Let's say this is a Ford Mustang. The year will be 2022, and the color will be red. All right, let's check car2's attributes. And let's have car2 use its drive and stop method. This is a Ford Mustang. The year is 2022. The color is red. This car is driving, and this car is stopped. One other thing that we can do too is that within our methods here, let's replace car with the name of the model that we're working with. So this plus self.model plus is driving. Now this self keyword, think of it as you're replacing self with the name of the object that we're working on. If car1 is using its drive method, replace self with car1. If this is car2 that called this method, then replace self with car2. Think of it that way. And let's do the same thing for stop. This plus self.model plus is stopped. All right, probably don't need these anymore. So let's have car1 use its drive and stop method. This Corvette is driving, this Corvette is stopped. Let's try this with car2. This Mustang is driving, this Mustang is stopped. Now you can have them do things independently too. Let's have car1 use its drive method and car2 use its stop method. This Corvette is driving and this Mustang is stopped. In conclusion, a class can function as a blueprint to create objects. We can assign attributes, what describe an object is or has, and methods, what each object can do. And then within our class, we have a special method called the init method. We can pass in some arguments and assign these arguments to each object's attributes. And then we can reuse this class as if it was a blueprint, so we can create more objects out of it. So that is the basics of object-oriented programming in Python. If you would like a copy of all this code, I will post this in the comment section down below. But yeah, that's the basics of object-oriented programming in Python. Hey, what's going on everybody? It's your bro. Hope you're doing well, and in this video I'm going to explain the basics of class variables in Python, so sit back, relax, and enjoy the show. Here's a super quick video on the differences between class and instance variables. For this example, let's say we have 2 car objects named car1 and car2, and I'm just passing in a bunch of values to each of these car constructors. Now within my class car, I have my init method, also known as the constructor, and what I'm doing is assigning all of these values to the variables found within my car constructor. These variables declared inside of the constructor are known as instance variables, and each object can have their own unique values assigned to each of these variables. Now, where a class variable is different is that a class variable is declared inside the class, but outside of the constructor. And what we can do is set some default values for some variables. Let's say we would like to add an additional variable. Let's say wheels. Wheels equals, and we can set a default value for all instances of this class for each car object that we create. So we set wheels to equal 4. This is an example of a class variable. Whenever we create a car object, we can pass in a unique make, model, year, and color. But by default, they will all have 4 wheels. Now, if I was to print the amount of wheels that car1 and car2 have, they will both have 4 wheels. It's as if we're setting a default value. If I change this to 2 wheels, well then these cars have 2 wheels. Maybe they're motorcycles or something. Now you can actually change these values. Each object will have their own copy of this variable, but you can set it to a default value. So let's say car1 is a motorcycle. Car1.wheels equals 2. So if I were to print car1's wheels along with car2, car1 will have 2 wheels, but car2 is still using that default amount of wheels, which is 4. Now, there's another way in which you can access a class variable. You don't necessarily need to create an object to do so. You can just use the name of the class. So what I'm going to do is turn all of these lines into comments, and I will print the amount of wheels that our class has. So type in the name of the class, car with a capital C. It should be the same name as your class name, followed by the name of the class variable, car.wheels. But make sure you spell it right. All right, so this will display 4 wheels. Now, what if we decide to change the class variable through our class? Well, that will affect all instances of our class. So let's say car.wheels equals 2. It's as if we change our mind and we have decided to create motorcycles instead of cars. Well, if we were to change the wheels class variable through the use of our car class, well then it's going to affect it for all instances of this class. You can see that both car1 and car2 now have 2 wheels. When we just changed car1's wheels, it did not affect car2 at all. So that's the main difference between a class variable and an instance variable. An instance variable is declared inside of a constructor, and they can be given unique values. With class variables, they are declared within a class, but outside of the constructor, and you can set a default value for all instances of this class, for all unique objects that are created, and then you can change those values later too. So if you would like a copy of all this code, I will post all of this in the comment section down below. But yeah, that is the basics of class variables in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain inheritance in Python, so sit back, relax, and enjoy the show. Let's talk about inheritance. The term inherit means to receive, derive, or be left with, and we can apply this concept to programming. Classes can inherit something, usually attributes and methods, from another class. These classes can form parent-child relationships, where a child will receive everything that the parent class has, much like you inherit genes from your parents, and classes can have children and give whatever they own to their children. And in today's video, we'll be creating a parent class called animal, and children of the animal class will inherit the common attributes and methods that all animals might have. To kick off this video, I think what we'll do is keep all of our classes within the same file, just so that it's easier for us to read and understand. Let's begin by creating a class called animal. So at the top, type class animal. And what are some attributes and methods that all animals should have? Let's say we have a class variable called alive, and we'll set this to true. If you're an animal, you begin by being alive. And what are some methods? How about an eat and sleep method? So let's define those. DEF, eat. What are we going to do when we call this method? Let's print something. Let's print this animal is eating. Let's also create a sleep method. DEF, sleep. What are we going to do when we call this method? Let's print something as well. This animal is sleeping. And we now have our animal class. Now let's create separate classes for specific types of animals. Let's say a class for rabbit, a fish, and a hawk, so we can make objects of those classes. So let's begin with a rabbit class. Class rabbit. Now to use inheritance, with the class that you intend to be the child class, after the class name add a set of parentheses, and then pass in the name of the parent class. In this case, it's going to be animal, so we will add that to the parentheses. So now rabbit is the child class and animal is the parent class. So the child class is going to inherit everything that the animal class has. So for the time being, I'm going to type pass. So this rabbit class will have access to a class variable called alive and an eat and sleep method. So let's define a fish and hawk class. And I'm just going to copy what I have here and just change rabbit to fish, and then do so again and change rabbit to hawk. This is our family tree. Animal is the parent class, and it has 3 children, a rabbit class, a fish class, and a hawk class. And for the time being, we're just going to write pass as a placeholder. So I bet we can create objects from these classes. So let's do so. Let's say we have an object called rabbit. Rabbit equals rabbit. Let's do the same thing for fish and hawk. All right, we now have three objects, rabbit, fish, and hawk. And let's take a look at their class variables. I bet they have an alive variable. Let's check that. So I would like to print rabbit dot, oh, would you look at that? This rabbit class has a class variable called alive, even though there's nothing within this class. Well, that's because we used inheritance. So each of these three children classes inherit everything from their parents, all of these attributes and methods. I bet they have eat and sleep functions as well, so let's check that. With fish, let's have fish use its eat method, and hawk will use its sleep method, hawk.sleep. So the rabbit is alive, the fish is eating, and the hawk is sleeping. Now, even though we have nothing written within each of these specific types of animal classes, all of these animals have access to these attributes and methods because of inheritance. And another benefit of inheritance is that we don't need to keep on copying and pasting this code. For example, let's say we were not using inheritance, so we would not need an animal class. We could write our code this way, where we would just copy and paste everything underneath each of our classes. So what if we need to make a change to one of these methods, as in your boss says, you know what, let's change sleep to slumber, okay? Well, we would have to go to each of these classes and make the change manually. It's not too bad if you have like 3 classes, but what if you have hundreds? That's going to take a lot of effort. So wouldn't it be nice if we just list everything that each of these classes has in common, and then have all of these classes inherit from one common class? And then if you need to make any changes, you can do so just within this class. And this change will apply to all of the different child classes. So that's another benefit of inheritance. And not only does it make any changes easier, but each class can have their own unique attributes and methods as well, along with the attributes and methods that they inherit from their parents. So for rabbit, fish, and hawk, let's have each of these classes have their own unique method as well. So for rabbit, let's define a run method. If you're a rabbit, then you can run. So let's print this rabbit is running. And I'm just going to fix some of the spacing here. All right, if you're a fish, then you can swim. DEF, swim. Let's print this fish is swimming. And lastly, we have hawk. If you're a hawk, then you can fly. DEF, fly. Let's print this hawk is flying. Like I said before, not only do these specific types of animals have access to all of the attributes and methods that they inherit from their parents, but they can have their own attributes and methods as well. So let's test some of these methods. So we have our rabbit, fish, and hawk objects. Let's have rabbit use its run method, fish will use its swim method, and hawk will use its fly method. And here we go. This rabbit is running, this fish is swimming, and this hawk is flying. So in conclusion, classes can have children. The children classes will inherit everything that their parent class has, all of the parent's attributes and methods. But not only that, the children classes can implement their own unique attributes and methods as well. So that is inheritance. If you would like a copy of this code, I will post all of this in the comment section down below. But yeah, that's the basics of inheritance using Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how multi-level inheritance works in Python, so sit back, relax, and enjoy the show. Alright, welcome back everybody. Let's talk about multi-level inheritance. This is a concept where a derived class, also known as a child class, inherits from another derived class. Here's an example. Let's say we have a hierarchy of classes. There will be 3 levels to this. We'll create a family tree of living organisms. So at the very top, we're going to have a class called organism. Any class that inherits from the organism parent class will receive one attribute, one variable named alive, and this will be set to true. So if you are an organism, you begin by being alive. Now let's say we have a child class that will inherit from the organism parent class. Let's say animal. Class animal inherits from organism. So any animal that we create will have this alive attribute set to true. And all animals eat, so let's define a function that does that. At least I believe all animals eat. Let's pretend that they do. So this animal is eating. And now, why stop there? Let's create a class for a specific type of animal. I like dogs, so let's create a dog class. Class dog inherits from the animal class. And all dogs should be able to bark, so let's create a function to do that. And we'll print this dog is barking. Okay, so what we just did here is multi-level inheritance. We had a derived child class inherit from another child class. So it's kind of like this dog class is the child, animal class is the parent, and then the parent of the parent class would be like a grandparent, right? And then if you added another layer on top of that to this hierarchy, well then the parent of the grandparent would be like a great-grandparent. That's how I think of it, at least. Now let's create a dog object just to verify that everything's working. So let's call our dog, dog, and our dog object should have access to an attribute named alive. And our dog object receives that attribute from the organism class. And this will print true if I were to print whatever this attribute contains. And our dog should be able to eat because it receives this method from the animal parent class. And lastly, our dog should be able to bark, and that method is defined within its own class. So that's how multi-level inheritance works. It's a concept where a child class will inherit from another child class. I like to think of it like a family tree, where a child class will have a parent, and the parent of that parent would be like a grandparent, basically. So if you would like a copy of this code, I will post all of this to the comment section down below. But yeah, that is how multi-level inheritance works in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how multiple inheritance works in Python, so sit back, relax, and enjoy the show. Alright people, multiple inheritance. Multiple inheritance is the concept where a child class is derived from more than one parent class. Here's an example. Let's say that all of our children classes are going to be certain types of animals, and we would like our animal classes to inherit from either the prey parent class, the predator parent class, or both depending on what type of animal it is, because some animals in the animal kingdom can be both prey and predators. And one example that comes to mind would be fish. Fish will eat smaller fish, but also can get eaten by larger fish. So here we have two classes, prey and predator. Each has a dedicated method. If a class inherits from the prey parent class, they will have access to a flee method, which will print this animal flees. If a class inherits from the predator parent class, that class will have access to a hunt method that will print this animal is hunting. And it's possible that some animals can do both. They can both flee and hunt, but they'll need to inherit both of these classes, both prey and predator. And that's where multiple inheritance comes in. Now let's create some classes based on certain types of animals. Let's say we have class rabbit, and rabbit will inherit from the prey class because rabbits are typically prey and not predators. But I don't know, there could be some killer rabbits out there. Haven't run into any yet. Let's have class hawk inherit from the predator class. And lastly, fish. And fish can be both prey and predators, so they will inherit from both classes. And we just separate each class with a comma. So prey, comma, predator. And it's as simple as that. Now let's create an object from each of these classes. We have rabbit equals rabbit. Hawk equals hawk. And fish equals fish. Now let's just verify all of the different methods that each of these objects inherited. So our rabbit should have access to a flee method, but no hunt method. And let's just test that. Yep, this animal flees. And my hawk object should have access to a hunt method, but no flee method. This animal is hunting. And lastly, my fish object has access to both a flee and a hunt method. And if you take a look on the right-hand side of this pop-up window, it shows the class that it inherited this method from. So flee comes from the parent class of prey, and hunt comes from the parent class of predator. So my fish can both flee and hunt, because it's typically considered both prey and predators. This animal flees, this animal is hunting. So that's basically what multiple inheritance is. It's a concept where a child class is derived from more than one parent class. So that's basically multiple inheritance. I'll post all of this code to the comment section down below, and well, yeah, that's how multiple inheritance works in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about method overriding in Python, so sit back, relax, and enjoy the show. Here's a super quick video on method overriding. I have two classes, a class called Animal and a class called Rabbit. Rabbit inherits from the Animal class, therefore Rabbit is the child class and Animal is the parent class. Within the Animal class, there is one method, a method called eat, and when you call this method, all this will do is print this animal is eating. The Rabbit class inherits from the Animal class, therefore Rabbit has access to this eat method. And if I were to create a Rabbit object and this Rabbit used its eat method, well then, this is going to print, this animal is eating. Now, method overriding is the ability of an object-oriented programming language to allow a subclass, also known as a child class, to provide a specific implementation of a method that is already provided by one of its parents. In this case, we're going to override the eat method, and what we can do is provide a more specific implementation for the Rabbit class. And now to override a method, what we'll do is that within the child class, we need to define a method with the same matching method signature. That is the combination of a method's name plus its parameters. Both of these together are known as a method signature. Within the child class, we will define an eat method with the same parameters. def, eat, and in this case, the only parameter is self, just to keep this simple. And what we'll do is that we'll provide a more specific implementation of the eat method specifically for rabbits. So let's print something more closely associated with rabbits, such as this rabbit is eating a carrot. Now, if I were to run this program again, we will instead use this implementation of the eat method instead of the one that it inherits from its parent class of animal. Basically speaking, an object will use a method that is more closely associated with itself first before relying on a method that it may inherit from a parent class. In this example, we're using this version of the eat method specifically for rabbits instead of the version that we inherit from the parent class of animal. That is the basics of method overriding. I will post this code in the comment section down below. And well, yeah, that's how to override a method using Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys all about method chaining in Python, so sit back, relax, and enjoy the show. Alright everybody, let's talk about method chaining. Method chaining is used to call multiple methods sequentially, and each call performs an action on the same object and returns self. Here's an example of how method chaining would be useful. Let's say we have a class named car. Car has four methods: turn on, drive, brake, and turn off. They will all just print a simple message beginning with turn on. Turn on will print, you start the engine. Drive will print, you drive the car. Brake will print, you step on the brakes, and turn off will print, you turn off the engine. Let's say we have a car object, car equals car, and I would like my car object to use its turn on method immediately followed by the drive method. With how we've been coding things previously, we may write something such as the name of the object, in this case car, dot, and then the method to use. I would like my car to use the turn on method, followed by car dot drive. So currently, this will take 2 lines of code, but this will print, you start the engine, and you drive the car. Now, with method chaining, we can call multiple methods sequentially. Now, the format on this is going to be a little bit different. And if we were to write the same code using method chaining, it might look a little something like this. After the first method call, we would add dot, and then an additional method that we would like to call. So, for example, after the turn on method, we'll immediately call the drive method. But there's one more thing that we need to add when we're using Python to do method chaining. So normally, this by itself will not work. When we call a method in Python, if there is nothing that is returned, Python will return none. So as you can see here, attribute error, none type object has no attribute of drive. So we need to return self under each method that we're using method chaining with. So let's add return self to each of these methods. So let's do that for drive, brake, and the turn off method. And this should work now. You start the engine, you drive the car. So think of it like this. After we finish calling this method, Python is going to return self. So it's going to return car. So then we'll immediately use car.drive. Now here's another example. Let's say I would like to call the break method followed by the turn off method. So that would be car dot break parentheses followed by dot turn off. So this will print you step on the brakes, you turn off the engine. Now here's an extreme example. Let's say we would like to call all four methods in order. So that would be car dot turn on followed by dot drive dot brake dot turn off. So this will call all four methods in order, starting with the leftmost method. You start the engine, you drive the car, you step on the brakes, you turn off the engine. Now, if you have one long method chain like this, it might become difficult to read after a while, so what I would recommend if you're doing a lot of method chaining is that after each method call, just hit enter to move each method call down to a new line. So it'll look something like that. And this backslash might be inserted. This is a line continuation character. So this is a little more readable, but it still does the same thing basically. All right, everybody, so that is method chaining. It's used to call multiple methods sequentially, and each call performs an action on the same object and returns self. If you would like a copy of this code, I will post all of this in the comments section down below. But yeah, that is how to do a method chaining in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well, and in this video I'm going to explain the super function in Python. So sit back, relax, and enjoy the show. Well then, since you clicked on this video, I should probably discuss the super function. Now, the super function is used to give access to the methods of a parent class. It returns a temporary object of a parent class when used. Here's an example of why the super function would be useful. Let's take this program that I've written. There's three classes, a class called rectangle, which is the parent class to two children classes, square and cube. And all we're doing is creating a square object and a cube object, but we need to pass in a length and a width for squares, and a length, width, and height for cubes. Now with programming, we don't like to repeat code, we like to reuse code, and if you take a look within my init methods for both square and cube, we're repeating self.length equals length and self.width equals width twice for our init methods. So one thing that we can do, any similarities between the square and cube class, we can place within the rectangle class and then reuse this code. So what I'm going to do is copy this init method within our square class and paste it within our rectangle parent class. And then in order to access this init method, we can use the super function. So we no longer need these two lines of code. What I'm going to do is ask the rectangle class to use its init method. So we're going to type super parentheses dot and then the name or the function of the parent class that we would like to use. And I would like to use the init method, but I need to send a length and a width because it requires that. So let's send these. So we're going to pass in our length and our width. And now we can do the same thing for our cube init method. So I will copy this line of code. We no longer need these two lines of code because we will be reusing our init method within the parent class of rectangle, but we'll still need to keep this line in to assign the height because that's a difference between our square and cube class. And now we can just reuse this init method within the rectangle parent class. Now I'm thinking that we should probably test to see if length and width are assigned to these attributes, and one way that I think would be fun would be to create an area method for squares and a volume method for cubes. So let's define an area method within the square class, def area, and I would like to return self.length times self.width, and we can create a volume method within cubes. So let's do that. Def, let's change this to volume. We'll multiply length times width times height. But we need to type self.height. And we can call these methods to get the area of a square or the volume of a cube. Let's print square dot area and then cube dot volume. So if our init method is actually being used, we should have a length and the width assigned to these attributes. And it looks like we do. In conclusion, the superfunction is used to give access to the methods of a parent class. It returns a temporary object of a parent class when used in order to access the methods of the parent class, also known as a superclass. And in this example, within the init methods of both square and cube, we immediately called the init method of the parent class to pass in some arguments that both of these classes have in common. So if you would like a copy of this code, I will post all of this in the comments section down below. But yeah, that is how the superfunction works in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to explain how abstract classes work in Python, so sit back, relax, and enjoy the show. Hey, what's good everybody? Let's talk about abstract classes. Now, abstract classes prevent a user from creating an object of that class. Think of an abstract class more as a template. It's an idea, it's not real. It's like a ghost class, basically. Plus, an abstract class compels a user to override any abstract methods within a child class. So it's also a form of checks and balances as well, which we'll discuss later. Now, here's a small program that I've written. Let's say we have three classes, class vehicle, car, and motorcycle. Car and motorcycle are the children classes of the vehicle class. Now, within this vehicle class, we have a go method, but I'm currently only defining it, not actually implementing it, so I'm just writing pass. Now, within car and motorcycle, we're overriding this method and creating our own implementation of this go method that we inherit. The go method for the car will print, you drive the car, and the go method for the motorcycle class will print, you ride the motorcycle. Now, currently, I'm creating an object of each of these classes. I have a generic vehicle object, car object, and motorcycle object. Now, after running this program, currently the go method within our vehicle class is not being implemented, so this won't print anything, but the go method within our car class will print, you drive the car, and the go method within our motorcycle class will print, you ride the motorcycle. With that being said, let's pretend that we're coding the next Need for Speed game, and we would like a user to create an object from a specific kind of vehicle, whether it's a car from the car class or a motorcycle from the motorcycle class. We would like to prevent a user from creating an object of the vehicle class because the vehicle class is too generic. We do not have all of the implementations set up for a vehicle. It would be like somebody unlocked the ghost car or the invisible car, which doesn't actually exist and is missing a lot of features. We need a user to create an object from a child class because these are fully fleshed out. And one way in which we can prevent a user from creating an object of this class is, well, to turn this class into an abstract class, which is what this video is all about. Go figure. Now, the first step to creating an abstract class is that we'll need some imports. So at the top of your program, write this, from ABC. ABC is an acronym for Abstract Base Class, ABC. From ABC, import ABC, all capital, comma, abstract method. All right, now with our vehicle class, the class that you intend to be the abstract class, add a set of parentheses, and our vehicle class will inherit from the ABC class. And now with any methods within your vehicle class, you're going to add this decorator at the top, at abstract method. All right, we should now be prevented from creating a vehicle object. Our vehicle class is now an abstract class, and we cannot give it a physical form, a physical manifestation. And if we attempt to, you can see here that we have a type error. Can't instantiate abstract class from vehicle with abstract methods go. So an abstract class is a class which contains one or more abstract methods, and an abstract method is a method that has a declaration but does not have an implementation. Now, by definition, an abstract class contains one or more abstract methods. If I remove this one abstract method within our vehicle class, well, we could still create a vehicle object. And I'm just going to turn this vehicle.go line into a comment because we don't have a go method anymore. As you can see, we can still create a vehicle object, which we would like to prevent a user from doing. So we need at least one abstract method within our vehicle class. So I'm going to go ahead and add this go method back in. An additional feature of abstract classes is that they compel a user to override any abstract methods within a child class. A method that is abstract has a declaration but does not have an implementation. So let's say that we create our vehicle class, our abstract vehicle class, and now we're creating the children classes of car and motorcycle. And let's say I'm not paying attention and I forget to add a go method. So if I just write pass within my motorcycle class, I'm currently missing a go method within my motorcycle class. Well, Python is going to prevent me from running this because we have a type error. Can't instantiate abstract class vehicle with abstract methods of go. So by inheriting from an abstract class, it's a good form of checks and balances to be sure that your children classes are not missing any implementations of any methods that they inherit. Here's an additional way of thinking of this. Our vehicle class is telling its children, if you're going to inherit from me, then you need to override this abstract method of mine, and if you don't, well, I'm not going to let you be instantiated. So in order for us to create a car and motorcycle class, we need to override the go method that they inherit from its parent class of vehicle and provide its own implementation. Now let's say we create an additional method. Let's say we have a stop method. So let's define that. def stop. For the time being, I'll write pass, and to make this an abstract method, add this decorator, at abstract method. Now, car and motorcycle both need to implement that method of stop. It's currently missing it. As you can see here, class car must implement all abstract methods, and the same thing applies for motorcycle as well. So we need to override this method and provide its own implementation. So let's remove that decorator, and let's print something. Let's print this car is stopped. And I'll do the same thing for motorcycle. So def stop. Let's say this motorcycle is stopped. And we'll call the stop method for each of these types of vehicles car.stop and motorcycle.stop. All right, and we can now create a car and motorcycle object because we are overriding both of these abstract methods found within the parent class of vehicle. All right, everybody, so that's the basics of abstract classes. It's a class which contains one or more abstract methods, and an abstract method is a method that has a declaration but does not have an implementation. And the benefits of using an abstract class is that they prevent a user from creating an object of that class. Plus, it compels a user to override any abstract methods found within a child class. So if you would like a copy of this code, I will post all of this in the comments section down below. But yeah, that is how abstract classes work in Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how we can pass objects as arguments. So sit back, relax, and enjoy the show. Ladies and gentlemen, in today's video I'm going to be demonstrating how we can pass objects as arguments. For this example, let's say we have a class car, and there is one class variable called color. Color equals none. What we'll be doing is calling a function that accepts an object as an argument as well as a color. So let's create a function named change color. Now make sure when you define this function it's not within the car class, then technically this would be a method of the car class. What we would like is a separate function outside of the car class. Now we need to set up some parameters. We would like to accept a car object as well as a color. So for the first parameter, let's say car, and make sure this isn't uppercase or capital because Python doesn't like that. Argument names should be lowercase. So when we pass in a car, we will give it a nickname of car. And we would also like to pass in a color. So let's set up a parameter called color. Now when we pass in a car, we will assign that car's color with whatever color that we receive. So car.color equals color. And now let's create some car objects. So let's say car1 equals car, car2 equals car, and car3 equals car. Currently, if I were to print their colors, this is what we'll see. Print car1.color and repeat the steps for 2 and 3. And we're not calling this function yet, so all of these colors should be set to none. They are basically cars with no color. They're, I don't know, iron or something. Whatever cars are made out of, aluminum, plastic, stuff like that. Okay, so now let's call this function change color, perhaps right here. So in order to call this function, we need to pass in a car object as well as a color. So let's pass in car1 and a color, perhaps red. And we'll repeat the steps for 2 and 3. So let's say car2 will be white and car3 will be blue. Now after calling this function, we have a car object and a color, and we're assigning the color of our car to whatever color that we receive. Now, these cars, in order, car 1, 2, and 3, are red, white, and blue. Now, one thing that you should know is that the name of this parameter that accepts our object doesn't necessarily need the same name as the class name that created the object that we're passing in. We could name this something else entirely, perhaps vehicle. You'll just want to be sure that this is at least descriptive of the kind of object that you would like to pass in. And we're not limited to just passing in car objects. We can pass in all sorts of objects, but we need to pass in an object as well as a color. So this time, let's create a class called motorcycle. Class motorcycle. And this class will also have a color set to none. So what we're doing is actually reusing this function for all sorts of different kinds of vehicles. Now let's create a vehicle. I'll just name this bike1 for short. Bike1 equals motorcycle. Now let's call the change color function, and we can pass in an object as well as color. This time, we will pass in our bike object as well as a color. I think black counts as a color. And let's print bike1's color. And this should work. We have red, white, blue, and black. In conclusion, we can pass objects as arguments to a function, much like what we've been doing with variables. However, the type of objects that we pass in may be limited based on the required attributes and methods that that given class or object might have, and we'll get more into this on the next video on duck typing. So if you would like a copy of all this code, I will post all of this in the comments section down below. But yeah, that is how to pass objects as arguments using Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to explain duck typing in Python, so sit back, relax, and enjoy the show. I hope you all like ducks because that's the topic of this video. Duck typing is the concept where the class of an object is less important than the methods and or attributes that that class might have. The class type is not checked if the minimum methods and or attributes are present. It's based off of a popular phrase, if it walks like a duck and it quacks like a duck, then it must be a duck. Here's an example. I have two classes, class duck and class chicken. Both duck and chicken have walk and talk methods, but they print something different. With the duck class, the walk method will print, this duck is walking, and the duck talk method will print, this duck is quacking. The chicken class has the same named methods, walk and talk, but they print something slightly different, a slightly different variation. The print method will print, this chicken is walking, and the talk method will print, this chicken is clucking. Now let's say we have a third class, a class called person. Now there is one method within our person class. Let's say we're attempting to catch a duck. We'll pass in self, and we need to pass in a duck object as an argument. So let's type duck. Now within this method, we'll have our duck use its walk method as well as its talk method. Duck.walk and duck.talk. And then maybe we'll print something such as, you caught the critter. Now let's create an object from each of these classes. Let's create a duck object. Duck equals duck. A chicken object, chicken equals chicken. And lastly, person. Person equals person. Now, if we would like our person to use the catch method, we need to pass in a duck as an argument. So with our person, let's type person.catch. And we need to send a duck object because that's a required parameter here. So we're passing in our duck object that we created, and as soon as we catch the duck, it's going to use its walk and talk method, and then we'll print, you caught the critter. So as you would expect, this will print, this duck is walking, this duck is quacking, you caught the critter. Now, with duck typing, we can pass in a different type of object as long as it has the same methods and or attributes as our duck. We could pass in a chicken because a chicken can also walk and talk. So this time, let's pass in our chicken as an argument. And this will still work even though our parameter is set up to take a duck object. This chicken is walking, this chicken is clucking, you caught the critter. In layman's terms, think of it like this. Python is examining this chicken object It's using its walk method, it's using its talk method, which are required, and Python is saying, well, that's close enough. Remember, if it walks like a duck and it quacks like a duck, then it must be a duck. So duck typing is the concept where the class of an object is less important than the methods and or attributes that it might have. The class type is not checked if the minimum methods and or attributes are present. Now let's say with our chicken object, our chicken can no longer walk. Well, we cannot pass in our chicken object anymore. We have an attribute error. Chicken object has no attribute walk. So Python took a look at this chicken and noticed that it does not have a walk method. Well, it's not walking like a duck, but it's talking like a duck, so it doesn't count as a duck because it doesn't have its walk method. In conclusion, the class type of an object is not as important as the methods and or attributes that that class might have when using duck typing. The class type will not be checked if the minimum methods and or attributes are present. Since chickens can both walk and talk like ducks, then they can be a substitute for ducks when we pass in our duck object to this method. So if you would like a copy of this code, I will post all of this in the comment section down below. But yeah, that is the basics of duck typing in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to discuss the walrus operator in Python. So sit back, relax, and enjoy the show. Alright people, I hope you like walruses because that's the topic of this video. We'll be discussing the walrus operator, also known as an assignment expression. It's a colon followed by an equal sign, and it kind of looks like a walrus on its side. Now this is a new feature for Python 3.8. What it does is that it assigns values to variables as part of a larger expression. Here's an example of why the walrus operator would be useful. Let's say we have a variable named happy. Happy equals true. If you're not happy or you're feeling so-so, you can set this to false if you want. So let's print the value contained within happy. So this will print true to the console window. Now, wouldn't it be cool if we could combine both of these statements together? So we would want to say something such as happy equals true, and then print it to the console window using one line of code. Well, normally we can't do this using the standard assignment operator. Now, one thing that we can do is use the walrus operator. This assigns a value to a variable as part of a larger expression. So this would technically be allowed if this assignment operator was instead an assignment expression. The walrus operator, happy, walrus, true. And when they're all within a print statement, we can assign a value to a variable and use it as a part of a larger expression. So as you can see, this new variable of happy was assigned and used in one expression. Now here's a more practical example of why the walrus operator would be useful. Let's say we have the small program. What this will do is consistently ask you what food do you like and put it into a list called foods. Foods equals list, while true, food equals input. What food do you like? If food equals quit, break, then append our list of foods with this new food item that we have. Okay, let's run this then. So this while loop will continue as long as I don't type in quit, and it will consistently ask me what food do I like and place that food item into a list named foods. So let's begin. What food do I like? Well, I do like pizza, I like sushi, and I like ice cream. And that should be enough for me. I'm going to type in quit to exit this program. Now let's write the same program, but instead use a walrus operator so that we can write this program using less lines of code. Now, if I were to use the walrus operator, this is how I would write the same program. We would still need our list. Foods equals list. Now for my while loop, it's going to look something like this. While, food, walrus operator, input, what food do you like? Alright, this is the assignment portion. Now we can use this assignment portion within a larger expression. So let's also check to see if our input does not equal quit. Alright, so then after each iteration of this while loop, we will take our list foods dot append food. And that is it. So we have written the same program in about half the lines of code that we did previously. So let's test it. What food do you like? Pizza, sushi, ice cream, and quit. Well, everybody, that is the basics of the walrus operator, also known as an assignment expression. It's a new feature for Python 3.8 and beyond, so if this doesn't work for you, I would check to see what version of Python you're using first. It assigns values to variables as part of a larger expression. If you would like a copy of this code, I will post all of this in the comment section down below. But yeah, that is how the walrus operator works in Python. Hello, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to show you guys how we can assign a function to a variable in Python, so sit back, relax, and enjoy the show. Hey all, in today's video I will show you all how we can assign a function to a variable. This video will be a prerequisite for a few videos I have coming up regarding functions. Now let's say we have a function named hello, and all we'll do is print the word hello. And as you know, to call this function, you would type the name of the function followed by a set of parentheses, and this will print the word hello. The set of parentheses that comes after a function's name is the portion that will call the function. If you were to remove that set of parentheses afterwards, we would not in fact call that function. Now with Python will pretty much treat everything as objects, including functions. So there's something I want to show you guys. If I was to print the name of my function hello, what will be displayed is the memory address of this function. This is the memory address of where this function is located within my computer's memory, and it's in hexadecimal. Think of it like a street address, such as 123 Fake Street. This is the address of where this function is within my computer's memory, and each time that I run this program, this number can change, as you can see here. Now, one thing that we could do, we could assign this address to a variable. Let's say hi equals hello. And be sure that you're not adding that set of parentheses afterwards, because then you would be calling the hello function and returning the result to hi. So hi equals hello, no parentheses. And if I was to print hi, well, the address of hello and hi will be at the same memory address. Both of these numbers are the same. Now, what do you imagine would happen if I was to call the hi function after we assign the memory address of hello to hi? Well, then what we'll end up doing is calling the hello function, even though we're listing that we would like to call the hi function even though it doesn't exist. So it's as if this hello function has two names. You can either use hello or you can use hi. And let me demonstrate that. So you can call either hello, hi, or both for this example. That's because we're assigning the memory address of hello to this variable of hi. So we could treat hi as a function. It's kind of like an alias where this function has two names. Now here's another demonstration. Let's say that we would like to assign our built-in print function to a variable. So let's say, maybe say equals print. And when I say print, I'm referring to the print function. And be sure you're not adding that set of parentheses afterwards. Now, if I need to print something to the console window, I can either use print, like what we've previously been doing, or I could use say, because say has the same memory address. Let's say, perhaps, whoa, I can't believe this works. Surprised face. All right, so we can call the print function by saying the word say. Say all of this text, and this will print all of this text, well, say all of this text to the console window. Under normal circumstances, I'm not sure why or when you would need to assign the print function to a variable, but you can, and well, that's kind of cool, so I thought I'd show you guys that. So everybody, that's how to assign a function to a variable. Like I said, we'll be building upon this topic, so you want to be sure that you understand this. Alright then, well, if you would like a copy of this code, I will post all of this to the comment section down below, but yeah, that's how to assign a function to a variable in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in today's video I'm going to explain higher order functions in Python, so sit back, relax, and enjoy the show. Alright, ladies and gentlemen, let's talk about higher order functions. These are functions that do one of two things. One, they either accept a function as an argument, or two, they return a function as output. And in Python, this is totally allowed because functions are also treated as objects. I'll give you guys an example of both of these, but let's begin with number one. Here's an example of number one. Let's say that I have two functions named loud and quiet. Both of these functions will accept a string as an argument. Loud will return that string all uppercase, as if we're shouting something. Quiet will return that text all lowercase, as if we're whispering something. Now I'm going to create a third function called hello. And this will be the higher order function. It accepts a function as an argument. I'm not sure if we're going to be passing in loud or quiet. Whatever it is, I'm going to give it a name of func, short for function. Each of these functions will return some text, either all uppercase or lowercase. I'm going to assign that to text. Text equals the name of our function. We're not sure what it's going to be, and I will pass in some text in order to call one of these functions. I will pass in just the word hello, that's capitalized. And at the end, I will print whatever text that we have. In order to call this function of hello, I need to pass in a function as an argument. Do I want to pass in loud or quiet? Do I want the loud variety of hello, where all of the text will be uppercase, or the quiet variety of hello, where all the text will be lowercase? I would like to pass in loud because I want to make my text all uppercase. So I'm typing the name of the higher order function and passing in a function as an argument. And the result is that the word hello will be printed to the console window, all uppercase. Now here's a rundown of what just happened. We're calling the hello function and we're passing in loud as an argument. We're naming loud as func while we're within this hello function. Text equals loud, and we're sending a string of text that says hello. We're returning that text, all uppercase, assigning it to a variable called text, and printing that text to the console window. Now, if I would like to use the quiet variety of hello, then I'm going to pass in quiet as an argument. So quiet will make all of this text lowercase. All right, people, so that's example one of a higher order function. A higher order function is a function that accepts a function as an argument. This hello function is an example of a higher order function because we're accepting either loud or quiet as arguments. All right, people, let's move on to the second part of this definition for higher order functions. A higher order function is a function that returns a function. I'm going to give a different example this time. Let's say we have a pair of nested functions. The outer function will be named divisor, and we will accept a number as an argument that we will call x. A divisor is a number that is used to divide another number when using division. And inside this function, we have an inner function named dividend. Dividend is the number that's going to be divided, and we will call the argument that is passed in y. All we'll do is return y divided by x. We're dividing the dividend by the divisor, y divided by x. Now, within the outer function, but not within the inner function, we're going to return our dividend function. So a higher order function is a function that returns a function. Divisor is a higher order function because we're returning dividend. Now, if I would like to access this nested dividend function, I first need to call the outside divisor function and pass in a number as an argument to serve as the divisor. The divisor function is going to return my dividend function, which we can then assign to a variable. So the variable I'm going to name divide. Divide equals, and I need to call divisor and set a divisor. Let's say that I would like to divide all numbers by 2. So I will set x to be 2. And now, for the dividend, I will print, call the divide variable, and pass in a number as the dividend, the number that's going to be divided. And let's say I would like to divide 10 by 2. And this will work. As you can see, we have 5 in the console window. So let me explain what just happened here. So our program begins here. Divisor, and we're passing in 2. X will be 2, and it will stay that way until we finish this program or until we reassign x. Now, x equals 2. We're skipping this function because we did not call it yet. We're returning dividend and assigning it to a variable. And we can call a variable if it has the memory address of a function, which is what we're doing in this line. Now we're calling dividend and passing in 10. So y equals 10 and x still equals 2. We're returning 10 divided by 2 and printing it to the console window. Well, everyone, in conclusion, a higher order function is a function that either 1. Accepts a function as an argument, or 2. They return a function. The format is a little bit strange and we're not quite used to it yet, but in future videos we'll have more practice with higher order functions. If you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, that is how higher order functions work in Python. Yo, what's going on, everybody? It's your bro, hope you're doing well. In today's video, I'm going to explain Lambda functions in Python, so sit back, relax, and enjoy the show. Alright, ladies and gentlemen, let's talk about lambda functions. These are functions that are written in one line and use this lambda keyword. They accept any number of arguments, but they only have one expression. Think of it as a shortcut. They're useful if you need a function for only one use or a short period of time, and then you're just planning on throwing away that function afterwards. Here's the syntax for a lambda function. You type lambda, you add the parameters, followed by a colon, and then your expression. Let's say we have this function named double. Double accepts one argument that we will name x. We're returning x times 2, effectively doubling it. So if I need to call this function, I would type double and then pass in a number as an argument. So the result, if I pass in 5, would be 10. Now let's write the same function, but instead write it as a lambda function. So let me turn these lines into comments. Now the first step is to type lambda, then our parameters. We only have one parameter, and that is x, colon, and then our expression. We would like to return x times 2. Now this lambda function is going to return a function object, and we can assign that much like what we do with variables. Let's say double equals lambda x colon x times 2. And in order to call this lambda function, we're going to type double, then a set of parentheses to call this function, and then pass in our arguments. So let's say that x equals 5, and then we're going to double it, and the result is 10. So that's the syntax for a lambda function. You type lambda, your parameters, colon, and then your expression. This time, let's say that we have two parameters. We have two numbers that we want to multiply by each other. So let's say that this function will be called multiply. Multiply equals lambda x comma y, because we have two parameters, colon, followed by our expression. We would like to multiply x times y, and that is it. Now in order to call multiply, we need to pass in two arguments. If I were to pass in just one, well, we'll have a type error. So let's pass in 5 and maybe 6. And the result is 30. Now let's try three parameters. Let's say we would like to add three numbers together. Let's say add lambda x comma y comma z. So we have all of our parameters, we have our colon here, and then we need our expression, x plus y plus z. And let's add 5, 6, and 7 together. The result is 18. Now let's try something a little more complex. Let's pass in some strings this time. I'll create a function named full name. Full name equals lambda, first name, comma, last name. The expression is going to be first name plus perhaps a space plus last name. Now I need to pass in a first name and a last name. Full name, and you can use your own name for this example if you want. Let's say bro, comma, code. Yep, this will print your first name and your last name to the console window. Now let's take it a step further. Let's say we would like to check somebody's age once using a lambda function. We would like to check to see if they're 18 or older because they're signing up for something perhaps. Let's say a credit card. So let's create a function object, age check equals lambda. We have one parameter, somebody's age, colon, and then our expression. Let's type true if age is greater than or equal to 18, else false. To call this age check function, we need to pass in an age. Let's say the user is 12 and they're trying to sign up for a credit card. Well, this will return false. Let's say they're 18 now, and this will return true. So that's a lambda function. It's a function that is written in one line using this lambda keyword. They accept any number of arguments, but they only have one expression. Think of it like a shortcut, and they're useful if you need to use a function only once and then you're just planning on throwing it away afterwards. So if you would like a copy of all of this code, I will post all of this to the comment section down below. But yeah, those are lambda functions in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how we can sort iterables in Python, so sit back, relax, and enjoy the show. Well, welcome back everybody. In this video I'm going to show you all how we can sort data using Python. We'll begin with the sort method, which is used with lists, and the sort function, which is used with iterables, and that would include lists. Let's start with something very basic, and then we'll crank up the difficulty one step at a time. I have a list named students, and I have a bunch of student names within this list. we have Squidward, Sandy, Patrick, SpongeBob, and Mr. Krabs. Let's say that all of these students are taking a college course, perhaps on marine biology. What I would like to do is to sort this list in alphabetical order, and to do that, we have a method that is built in with lists. So type the name of your list, students, dot, sort. And it's easy as that. And to display this list, I think I'll use a for loop. For I in students, print I. And there you go. That's how to sort a list. Starting with the top, we have Mr. Krabs, then Patrick, Sandy, SpongeBob, and Squidward. The sort method of lists can accept keyword arguments. There are two optional keyword arguments that we can pass in. We can pass in key and or reverse. We'll cover key a little bit later. If we set reverse to true, then our list will be sorted by reverse alphabetical order, beginning with Squidward, SpongeBob, Sandy, Patrick, then Mr. Krabs. Now, the sort method does not work with other iterables. It's a built-in method for lists. If our list of students was instead, let's say, a tuple, well then the sort method is not going to work. You can see here that we have an attribute error. Tuple object has no attribute of sort. That's where the sort function would come in, because that's useful for other iterables. You can also use this for a list too, I suppose. The sort function will return a sorted list. So let's use the sort function this time, and we'll assign the result to a list called sorted students equals sorted, and then we need to pass in an iterable, and we have the option of passing in a key and or reverse. The iterable that we'll pass in as an argument is our tuple named students. So this line will be sorted students equals sorted students. Sorted students is a list. The sorted function will return a list, but it accepts an iterable as an argument. And to display this, we should change for I in students to for I in sorted students. And now this function will accept our iterable, our tuple, and create a sorted list. And all of these are in alphabetical order. And to reverse this, we can pass in the keyword argument of reverse equals true. And now our list is sorted in reverse alphabetical order. All right, we're going to take it up a level. Welcome to level 2. Sometimes data isn't always as simple. Here we have a list of tuples. Each tuple has a corresponding student record. We have a name, a letter grade for their college course, and the student's age. Now, how can we sort this list of tuples by either the student's name, their grade, or their age? Well, that's where the key keyword argument is going to come in with sorting. If you take a look at this list of tuples, it somewhat resembles a spreadsheet. There's rows and then there's columns. The first column corresponds to student names, the second column are grades, and the third column are all the ages of the students. So by default, sorting by the first column is actually really easy. That's the default. So if we need to sort alphabetically, that would be the same process as before. We would type the name of the list, students, dot, sort. But if we were to print this iterable for I in students, instead of just the individual student names, we're going to get each tuple that we have. So now all of these tuples are arranged in alphabetical order, starting with the first column that we have, which are all the student names. Now, how can we sort these iterables by their second column? For this case, it would be student grades, or even the third column, which would be the student ages. Well, that's where the key keyword argument is going to come in. This is a keyword argument, and we set key equal to a function that's going to return the index of that specific column that we have. So let's say key equals grade. Grade is going to be a function object. Grade equals, and we can easily use a lambda expression for this. Lambda, let's say grades, colon, grades, and we will set an index of 1. Now the first index is 0. That's the first column because computers always start with 0. Column 2 would have an index of 1, and then column 3 would have an index of 2. So grade equals lambda grades, colon, grades, index 1. You can also rename these if you want. So students.sort, we're setting the key equal to grade, and grade is a function object via a lambda function. And now all of these students will be sorted by their grades, starting with Sandy, then SpongeBob, Mr. Krabs, Patrick, then Squidward. If this needs to be in reverse order, we can pass in that other keyword argument of reverse equals true. And for practice, if you wanted to sort all of this data by each student's age, then we would change grade to, let's say, age. Age equals lambda. We'll change grades to maybe ages, colon, ages. And the index would then be 2, because the first column here is 0, then 1, then 2, and change key to our function object of age. Now each student is sorted numerically, beginning with the smallest age, well, the youngest person, starting with SpongeBob, Sandy, Patrick, Squidward, then Mr. Krabs. And like I said before, if you want your data arranged in reverse order, you can set that keyword argument of reverse to true within the sort method. And all of our student data is sorted beginning with the eldest student, which is Mr. Krabs, then Squidward, Patrick, Sandy, and then SpongeBob. And for the last part of this video, let's say that we're working with some other iterable. Let's say we have a tuple of tuples instead. Well, we can no longer use this sort method because that only belongs to lists. You can also use the sort function with lists, and it will generate a new sorted list without changing the placement of the original. So let's say we have a tuple of tuples, and this will create a new sorted list. Let's call this list sorted students equals, then we'll use the sorted function. We need to pass in an iterable, and we can pass in both a key and or the reverse keyword argument. So the iterable would be students, and let's set the key equal to age. And I will not reverse it. We can keep it as it is. But let's change for I in students to sorted students. And that's how to use the sorted function to sort an iterable, including a list. Well, alright everyone, that's how to sort iterables in Python. If you would like a copy of all this code, I will post all of this to the comments section down below. But yeah, that's a basic way to sort iterables in Python. Hey, what's going on everybody? It's your bro, hope you're doing well. In today's video, I'm going to show you all how the map function works in Python. So sit back, relax, and enjoy the show. What up everybody? Let's discuss the map function. The map function will apply a function to each item in an iterable. That would include lists, tuples, things like that. And the map function accepts 2 arguments, our iterable as well as the function we would like to apply to each item within our iterable. For example, let's say that we have an online store. To represent this, I have a list of tuples named store. Each tuple within this list corresponds to an item for sale within our store. There's shirts, pants, jackets, and socks, and each item has a price in US dollars, let's say. Now what I would like to do is to convert all of the prices within my store to euros, and currently the conversion rate as of the filming of this video is $1 to 0.82 euros. So let's begin. We can easily convert dollars to euros with a lambda function. So let's say 2 euros equals lambda, the parameter will be data, colon, and the next part's a little bit tricky. Within a set of parentheses, to represent a tuple, we'll take data at index 0, that corresponds to the first column, comma, data at index 1. This represents the index of our prices. We're going to take data at index 1 times 0.82, and that's it. The first column will be left untouched, but the data in column 1 will be multiplied by 0.82. Now our map function is going to create a map object, but we can easily cast that to a different type of iterable. So let's say that store underscore euros equals map parentheses, and then we can pass in our function as well as our iterable. Our function is our 2 euros function, comma, and our iterable is our store. And that is it. Now, if you want to convert this map object to an iterable, you can easily surround this with a cast. I would like to convert this map object to a list, and we will now have a new store named store euros, which will have all of the different prices of our store in euros. And to display this, I'll use a for loop. For I in store euros, print I. And let's try it. Yep, that seems about right. All of the prices in our store are now in euros. Let's pretend that these prices are already in euros and we would like to convert these to American dollars. So we will use the same conversion rate, but divide by 0.82. So let's create a separate lambda function. $2 equals, I think I'll just copy this. But we are going to divide the first index of data by 0.82. And let's say store dollars to represent our store in dollars, because we're pretending now that it's currently in euros. And we will display for I in store dollars. So if all of these prices are in euros, we are now converting them to American dollars. But you may want to do some rounding, I suppose, to the nearest cent. Well, everyone, that is the map function. It applies a function to each item in an iterable. Those include lists, tuples, the like. You pass in your iterable and your function as an argument to the map function. So if you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, that is how the map function works in Python. Yo, what's going on, everybody? It's your bro, hope you're doing well, and in today's video I'm going to show you all how the filter function works in Python. So sit back, relax, and enjoy the show. Alright, let's discuss the filter function. The filter function creates a collection of elements from an iterable for which a function returns true. Now, what the heck does that mean? Let me explain. Let's say that we have a list of tuples named friends. Each tuple has the name of a friend as well as their age. I just made up some ages for all of these friends. What I would like to do is to create a separate list for all the friends that are 18 or older. So let's say that we're all going out drinking, and I would like to create a list of my drinking buddies because they're of drinking age. I'm in the United States and the drinking age is currently 21, but I think worldwide it's 18, so let's go with 18 for this example since I have a worldwide audience. Alright, now with this filter function, we have to pass in our iterable as well as a function to get anybody's age that is over 18. So let's begin by writing a lambda function for this expression here, our filter function. So let's say age equals lambda, data will be the parameter, colon, data at index 1. So the first index, the first column in this chart here would be 0 for all the names. The next index of 1 would be all the ages. Data at index 1 is greater than or equal to 18. And that is it. That is our lambda function. And now we're going to filter our iterable by this function of age. So let's write filter, pass in our function, which is age, comma, and our iterable of friends. Now this filter function will return a filter object. You can easily cast this. I would like to cast my friends list back into a list. And I will assign this to a new list. Let's say drinking buddies equals list, filter, age, and friends. And I should be able to print all of the friends that are 18 or older for I in drinking buddies. Print I. And we have Rachel, Monica, Chandler, and Ross. Well, everyone, that is the filter function. It creates a collection of elements from an iterable for which a function returns true. I like to think of it as the search results. We're searching for any results that meet this criteria, where age is greater than or equal to 18. And then you can create a separate collection or other list if you want from the results. But yeah, that is how the filter function works in Python. Yo, what's going on, everybody? It's your bro, hope you're doing well, and in today's video I'm going to show you how the reduce function works in Python, so sit back, relax, and enjoy the show. Well, I suppose we're on the reduce function today. The reduce function applies a function of our choosing to an iterable, and reduces that iterable to a single cumulative value. The way this works is that the reduce function performs our function on the first two elements of our iterable, and repeats the process until only one value remains. I kind of like to think of it like we're recycling elements within an iterable until a single value remains, our finished product. So how is this useful? Let's say that we're playing a game of Scrabble and we have a bunch of different letters within an iterable. A list is a type of iterable. So I have a list named letters and we have all of the letters we need to spell a word. What I would like to do is to reduce all of these individual elements into a single cumulative value. until only one value remains. So we can do that using the reduce function. You can also do this with the for loop too. There's multiple ways of doing this. So using the reduce function, we're going to import functools. And now, let's say we have our cumulative value stored within a variable named word. Word equals functools dot reduce. Now the reduce function has two arguments. The function we would like to apply to the first two elements, and then our iterable. The iterable is easy, that is just letters. So let's put that in, letters. And for the function, we can easily write a lambda function for this. Lambda, and now this function needs two parameters. Let's say x and y. Now what kind of function do we want to perform on the first two elements of our iterable? Let's combine them together. So let's say x plus y. And now let's print our single cumulative value of word. So this should print the word hello. I'm fairly confident that the word hello is worth like 20 points in Scrabble. Now let me explain what happened step by step. Our reduce function applies our function to the first two elements within our iterable. It performs this expression that we set, x plus y, but really we can write anything here. So we perform this expression on the first two elements. Then we repeat the process again using the result from the first time we used this expression and the next element. So we're combining x plus y again. And then we're just going to repeat this process until only one value remains. It's kind of like we're recycling all of these letters and creating a finished product out of all of these. That's how I think of it, at least. Here's a different example. Let's say that I would like to find the factorial of 5. So I have the numbers 5 through 1 within a list named factorial. So if I was to find the factorial of 5 via the reduce function, I would probably write something like this. So let me change word to, let's say, result. Result equals functools, reduce. Now our lambda function will be x times y, because with factorials, we multiply the next two numbers together. Then we take that result and then multiply the next one in this list. So the iterable will be factorial. And let's print what our result is. So the factorial of 5 should be 120. Now let's walk through this. We're taking the first two elements of this iterable, 5 and 4, multiplying together in this case. In the last example, we concatenated the strings together of x and y. In this example, we're multiplying them together. So we take the first two elements, 5 times 4, we take the result and apply it to the next iteration of x times y again. So 20 times 3 is 60. We repeat this process again. 60 times 2 is 120, and 120 times 1 is 120. So that's kind of how the reduce function works. It applies a function of our choosing to the first two elements of an iterable and repeats that process until only a single cumulative value remains. So that is the reduce function. If you would like a copy of all of this code, I will post all of this to the comment section down below. But yeah, that is how the reduce function works in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how list comprehensions work in Python, so sit back, relax, and enjoy the show. Alright everybody, so list comprehensions. A list comprehension is a way to create a new list with less syntax. You can also use a list comprehension to mimic certain lambda functions, such as in the previous videos where we used the map and the filter functions. And not only that, but a list comprehension is easier to read than a lambda function. But there is a formula that we're going to follow. When we create our list, within our list, we're going to write an expression for item in iterable. Now let me give you an example of where a list comprehension would be useful. Let's take this program that will create a list of all the numbers 1 through 10 squared. So if I were to print this, we'll get the numbers 1 through 10, whatever their square is, right? So we have 1 through 10, and the square of 10 is 100. So we wrote this program in 3 lines of code. We're creating an empty list, we're creating a for loop, and then we're writing an expression for what we want each loop iteration to do. Now let's write the same program but used a list comprehension, and we can write the same program with less syntax. So I would write something like this, and we're going to follow this formula. So our list is going to be named squares equals, then within a set of straight brackets, we're going to write our expression, which is this portion, I times I, for item, so that would be for I in our iterable, that would be range 1 through 11, because remember 11's exclusive. And then let's print our squares. Print squares. And there you go. We made the exact same program using a list comprehension. So basically speaking, you just follow this formula. You set your list equal to your expression, and our expression for this example is I times I for item for I in your iterable in range 1 through 11. So this took 3 lines of code, well, if you exclude us printing our list, and this program took 1 line of code. Now we can also use a list comprehension to mimic certain Lambda functions. I wrote a program where we will be filtering a list of student grades. Let's pretend that all of these students took some sort of exam. So we have one student that received a 100%, 90, 80, 70, 60, 50, 40, 30, and then one student got a 0 because they didn't show up. So what I would like to do is to filter all of these student grades into a list that only contains students that passed. And the criteria for a passing grade will be a 60% or above. So I would like to filter all passing students. And if I was to write this program using the filter function, I would probably write something like this. So I need a function and then my list that I'm working with. Lambda x colon x is greater than or equal to 60. We'll filter all of the results and then convert it to a list named past students. So the result will look something like this. I have 5 student grades in here with 100%, 90, 80, 70, and 60. Now let's write the same program using a list comprehension. Now there's just one portion to this formula for our list comprehension that we're going to add. At the end, we're going to add if conditional. We can check some sort of condition after each iteration. So let's write the same program using a list comprehension following this new updated formula that we have. So we need our list, which will be named past students equals, first comes our expression, and it's just I for this example, for item I in our iterable of students, and then if, we can check our conditional, if I is greater than or equal to 60. And this will have the same effect as our previous program, but instead it uses a list comprehension. Now, if your program has multiple output, if you need an else statement within your conditional, you're actually going to move this portion of the if conditional within our formula to right after the expression. So let's write an if else statement here. So let's say that instead of just excluding any student that didn't pass, we'll replace their grade with the word failed, and we can do that using an if else statement. So let's do this again. I'm going to copy what we have here, paste it, and we'll move our conditional from the end to just after the expression portion. If I is greater than or equal to 60, and you can see here that we need to add an else statement. Else will return the word failed. So we're replacing each instance of a failing grade with the word failed instead. So if your condition returns whatever I is, you can just add that to the end. If you need an if-else statement, you're going to add it right after the expression. So everybody, in conclusion, a list comprehension is a way to create a new list with less syntax. You can even mimic certain Lambda functions, which we did with the filter function, and it has the added benefit of being easier to read than a Lambda function. So you just follow one of these formulas depending on what you're trying to do. So you need at least list equals your expression for item in your iterable. If you have a condition that you want to check, you just add that to the end of your list comprehension. If you have an if-else statement, then you'll add that to right after the expression. So you just follow one of these formulas depending on how you want to write your program. So that is a list comprehension. If you would like a copy of this code, I will post all of this to the comments section down below. And well, yeah, that's how list comprehensions work in Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain dictionary comprehensions in Python, so sit back, relax, and enjoy the show. Okay, people, dictionary comprehensions. They're very similar to list comprehensions, except they're with dictionaries. That's it, video over. Okay, but seriously, a dictionary comprehension is a way to create dictionaries using an expression, and they can replace for loops and certain lambda functions. And all we have to do is follow this formula. Dictionary equals key, colon, our expression, for key value in iterable. So let's go over a few examples. Our first example, we're going to take this dictionary named cities in F. F is short for Fahrenheit. I have different city names as keys and relative temperatures as values in Fahrenheit. So New York is 32 degrees Fahrenheit, Boston is 75, Los Angeles is 100, and Chicago is 50. And what we'll be doing is creating a separate dictionary where all of these temperatures will be in Celsius using a dictionary comprehension. So let's follow this formula. Let's create a new name for this dictionary. Let's say cities in C, short for Celsius, equals, and we will follow this pattern. First our key, colon, then our expression. We'll go back to this in just a moment. For key, comma, value in our iterable of cities in F. And since we're working with a dictionary, we're going to use the items method. Now we just need to fill in this expression. There is a formula to convert Fahrenheit to Celsius, and it should be on the screen right about now. So let's follow this formula. So we'll take our value minus 32, and just for good measure, I'm going to put these within parentheses, and we will multiply all of this by 5 divided by 9. And that is it. So we have our key, our expression to convert Fahrenheit to Celsius, for key value in our iterable of cities in F, our previous dictionary. And let's test this by printing our new dictionary, cities in C. Actually, I think I'm going to round these numbers, just so it's more readable. So let's round all of this. There we go. So New York in Celsius is 0, Boston is 24, Los Angeles is 38, and Chicago is 10. So we created a new dictionary using a dictionary comprehension. Now with these dictionary comprehensions, you can add an if conditional to the end of this. So let's say that we have a separate dictionary of weather, like a description of the weather in each city. New York is snowing, Boston is sunny, Los Angeles is sunny, and Chicago is cloudy. Let's say that we would like to create a separate dictionary with a dictionary comprehension that only has cities where the weather is sunny. So I would write something like this. Let's say sunny weather will be the name of our dictionary, equals, and we'll follow this formula, and then we just tack on our conditional to the end. So it's kind of the same as before, really. So key, colon, and we don't really have an expression here, so let's just say value, then for key, comma, value in our iterable of weather dot items, then our conditional if value equals sunny, because we are only looking for sunny weather. And let's print this. Print our dictionary of sunny weather. And let me just make this more readable for you guys. And our new dictionary comprehension will create a dictionary of key values where the value is sunny, using an if conditional at the end of our dictionary comprehension. Here's a third example for you all. If you have an if-else condition, you can add that to where the expression is within your dictionary comprehension. So I'm going to reuse the previous dictionary for the first example where we have cities and their temperatures as values. So we're going to replace each temperature with a description of the weather. Is it warm or is it cold? So let's do that using a dictionary comprehension that contains an if-else statement. So let's say we have a new dictionary named desk, short for description, cities. It's a brief description of each city's temperature. So we follow this formula, key, then our if-else conditional for key value and iterable. Actually, I probably can copy all this just to save some time. Okay, so our iterable will be cities dot items, and our conditional is going to be we will return warm if our value is greater than or equal to, let's say, 40, else cold. And we will print our new dictionary of desk cities, description of cities. So New York is cold because it's 32, that's below 40. Boston is warm, Los Angeles is warm, and Chicago is warm. Now, if your condition gets somewhat complex, you can even call a separate function to keep your code more organized. So key, then we can call a function and pass in a value for key value in iterable. So I'm going to, again, reuse our city names and our temperatures, and this time we are going to call a function instead. I think I'll reuse this code from the previous example where we have a separate dictionary named desk cities, and I'm going to replace this if-else statement with a function. So let's say we have a function that is named check temp, and we will pass in our value, and we just need to define this function. So let's define that here. So let's define check temp, and our parameter is our value that we're currently working on within our dictionary value. Then we'll write if value is greater than or equal to, let's say anything above, how about 70 will return the word hot. Then else if, let's say 69 greater than or equal to value, and then value is greater than or equal to, how about 40, then we will return the word warm. And lastly, else return cold. And let me just fix some of the spacing. Now, depending on the temperature that is stored within each value of our dictionary, we will call a function that will return one of a few different outputs. So it's kind of like we're using the map function, the map lambda function. So let's print our description of cities. And we should get a short description of the temperature in each city after we call the check temperature function and then pass in each value from our dictionary. So New York is cold because it's 32 degrees Fahrenheit. Boston is hot because it's above 70. Los Angeles is hot because it's 100. And then Chicago is warm because that is 50, which is between 69 and 40 within our function. So that is a dictionary comprehension. It's a shortcut where you can create dictionaries using an expression, and they can replace for loops and certain lambda functions. So if you would like a copy of all this code, I will post all of this to the comment section down below. And well, yeah, that's how dictionary comprehensions work in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in today's video I'm going to show you how the zip function works in Python, so sit back, relax, and enjoy the show. Alright, ladies and gentlemen, welcome back. We're talking about the zip function today. The zip function will aggregate elements from two or more iterables. Iterables are those things like lists, tuples, sets, etc. And the zip function will create a zip object with paired elements from each iterable stored in a tuple for each element within our zip object. Here's an example. Let's say that we have two different types of iterables. I have a list of usernames, and a few usernames within here are dude, bro, and mister. And I have a tuple of passwords, and I have some very secure passwords, such as password, ABC123, and guest. What I would like to do is to zip elements from each iterable together so that they're in pairs, and each pair is going to be stored as a tuple within a zip object. And here's how we can do that. Let's say that we will create a zip object called users, and we will use the zip function. The zip function will take a varying amount of iterables. We're going to pass in our usernames and passwords and zip them together. So let's pass in usernames as well as passwords. And now our zip object of users is actually iterable. Zip objects are iterable, so we can use them within a for loop. So let's type for I in users and print I. And what we get is that we have a zip object of tuples, and each tuple is storing each pair of elements from our two iterables. Now, users is a zip object, and if you don't believe me, let me prove it. I'm going to print the type of users, and this will print that users is indeed a zip object, but you can easily convert this to a different type of iterable by using a cast. Let's say that we would like to convert our zip object into a list. So we'll surround the zip function with a cast to a list. And now the data type of users is now a list. What we have is a list of tuples, and each tuple is storing a pair of elements from our two iterables of usernames and passwords. Now currently, since we're passing in only two different iterables, we can easily make this a dictionary so that these are key value pairs. So let's cast our zip object as a dictionary, and to display all of the elements within our dictionary, all the key value pairs, we're going to change our for loop to this. For key value in users dot, and we will use the items method, print key, comma, value. Actually, I think I'm going to separate each of these with a colon just to make it more readable. And now when we zip these two iterables together, we end up with a dictionary of usernames and passwords, and the name of this dictionary is users. Now, you're not limited to just two iterables. You can add a third iterable or more. So this time, let's create maybe a list of last login dates, and I'll just call this login date equals, and why not make a list? And let's make up some dates. Let's say 1-1-2021, 1-2-2021, and 1-3-2021. Okay, so let's create a zip object of users, and we're going to zip usernames, passwords, and login date. And let's iterate over this. For I in users, print I. Now we have a tuple for each element, and instead of a pair, we now have a trio, I guess, of all of the different elements from each iterable. So in conclusion, the zip function will aggregate elements from two or more iterables and create a zip object with paired or grouped together elements stored in a tuple for each element within our zip object. So that is the zip function. If you would like a copy of this code, I will post this to the comment section down below. And well, yeah, that's how the zip function works in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well, and I'm going to explain the purpose of if name equals main in Python. So sit back, relax, and enjoy the show. During your programming journey, you may have encountered this strange statement of if name equals main. Now, what the heck does that mean? So, with Python files, also referred to as modules, by including this statement, it gives our modules some flexibility. One, a module that has the statement can be run as a standalone program, or two, this module can be imported and used by other modules if there's some sort of useful functions or other resources within this module to be imported. By including the statement of if name equals main, we're checking to see if a user is running this module as either a standalone program or they're importing it from another module. Behind the scenes, the Python interpreter will set special variables, one of which is double_name. It's a variable, and Python will assign the name variable a value of main if it's the initial module being run. And we can actually test that by printing double_name. So since this is the initial module being run, module 1 for my example, name is going to be assigned a value, a string, of main. Now check this out, I have two modules. What if I were to import module 2 and check the name variable of module 2? Let's try it. Import module 2. In order to access a variable from another module, I need to type the name of the module, module2 dot, and I would like to check the special name variable of module 2 and print it. So when you import a module, this name variable is going to be assigned the name of the module, in this case, module 2. This time, what if we change the roles around? I'm going to copy all of this text and paste it within module 2. We're going to import from module 1. We will print that special name variable of this module, module 2, and then print the name variable of module 1, which is being imported. Now, when I run this program, I'm going to instead run from module 2. Now, this time, that special name variable of module 2 is main, and the special name variable of module 1 is module 1, the name of the module. So by including a statement such as if name equals main, we're checking to see if this module is being run directly or indirectly. So let's test it. Within this statement of if name equals main, let's print running this module directly. Else, that must mean that we're running this module indirectly. So let's print running other module indirectly. Okay, so I'm going to go to module 1 and run from here. Running this module directly. Now, let's do the same thing with module 2, but we need to import module 1. And let's run from module 2. Running other module indirectly. For the time being, I'm just going to write pass within our if name equals main as a placeholder and get rid of our if statement. So let's say within module 1, there's a useful function or resource we would like to access from module 2. So let's say we have a function named hello, and all this will do is print the word hello. Let's just pretend that it's a useful function. Not really, but let's pretend. So in order to use this function from module 2, I need to import module 1, then type module 1 dot, and then the name of the function. So I'm going to run from module 2, and this will print hello. But what if I run this program from module 1? So right now, module 1 cannot be run directly as a standalone program, so I cannot print the word hello. So what I could do is within if name equals main, I can call that hello function directly. So let's run from module 1. Hello. One other thing that you might see too within the if statement if name equals main, there might be a call for a main function, and you can write the main body of your program within a main function. So everybody, in conclusion, the reason that people may include this statement if name equals main is that it allows our modules to have some flexibility. They can be run as a standalone program, or they can be imported and used by other modules. And this is because the Python interpreter sets that special variable of name with a value of main if it's the initial module being run. If you would like a copy of my code and my notes, I will post all of this to the comment section down below. But yeah, that's the purpose of if name equals main in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all a few useful functions related to times and dates using the time module in Python, so sit back, relax, and enjoy the show. Alright everybody, so the time module. Let's begin by importing time, and the first thing that I'm going to explain to you all is how we can find our computer's epoch, also pronounced as epoch. So this is a date and time in which your computer thinks time began. Think of it that way at least. So we use our epoch as a reference point. So to find your computer's epoch, it's going to vary based on your computer and your operating system. So to find your computer's epoch, type time.ctime, and as an argument we will pass in 0. Now what this method will do is that this method will convert a time expressed in seconds and convert it to a readable string. So if I was to pass in 0 and print it, well then this will display the date and time, which is my epoch, our reference point. So for me, my epoch is Wednesday, December 31st, 6 p.m., 1969. So I've just added a note that the ctime method will convert a time expressed in seconds since epoch and convert it to a readable string, a readable date and time. So for practice, let's pass in perhaps 1 million seconds and see what date and time that we receive. So our ctime method will return a date and time 1 million seconds past this epoch here. So that would be, for me, Monday, January 12th, about 7 a.m., 1970. Our next method is the time method of the time module. Let's print time.time method. And what this method will do is return the current seconds that have passed since our epoch using our computer's clock. So the number that I end up with is just over 1.6 billion, and this is in seconds. So for me, 1.6 billion seconds has passed since that date, which is my epoch. I believe it was December 31st, 1969. And every time that I rerun this program, you can see that the amount of seconds that has passed is actually increasing. So that is the time method. It will return the current seconds since your epoch using your computer's clock. And you know what? Just for fun, let's change the date and time on our clock and see what happens. So let's change the year to, how about the year 2000? Change and close. So let's see what number we get with the time method now. So we get just under 1,948,000,000 seconds have passed. And now if you need to retrieve the current date and time, well, there's one of a few ways in which you could retrieve that, but one way is that we can combine both of these methods of the ctime method and the time method of the time module. So let's print time.ctime, and we're going to pass in an amount of seconds into the ctime method as an argument. So within the ctime method, we're going to call the time method. So the time method will return an amount of seconds since our epoch, and the ctime method will convert that amount of seconds to a readable date and time. So the current date and time is Saturday, January 23rd, about 3 p.m., 2021. Now, there is more than one way to get the current date and time. Another way is to use the local time method, and the local time method will create a time object based on the current time. So what I'm going to do is create a variable called time object, and I just need to explain a few things about time objects. So to best explain this, I'm going to print our time object. Now, a time object is also referred to as a struct time object. It is made up of different keyword arguments. There's a year, a month, day, hour, minutes, seconds, day of the week, day of the year, and this keyword argument here has something to do with daylight savings time. So there's quite a few uses with time objects, and one way is that we can format them however we want, because right now this time object is not in a readable format. So to convert this time object into a readable string, we'll need the help of a separate function, and that is the strf time function. str is short for string, f for format, and time, well, for time, I guess. So this function needs two arguments, a format and a time object. So our strf time function will accept a format and a time object as an argument. So our format is really just a string of different directives, and to best explain these, I'm going to head to Python's official documentation on this subject. So here I am on Python's website regarding the time module, and underneath this section on the strf time function, there are different directives that we can embed within our format string that we pass in as an argument. Depending on the directive that we add, we can display a certain format of our date and time. So for example, if I was to pass in, let's say, percent lowercase a, then we will display the time object's weekday name. And you're not limited to just one directive, you can add any combination of directives. So if I was to add %m, well, we would display the month of our date time object as a number 1 through 12. So there's a bunch of directives here, and I'm going to be using some of these. So within a string for the format argument, I'm going to pass in %B for the name of the month, %D for the day, %Y for the year, %H for the hour, and to format this, I'm going to add a colon to separate hours and minutes, %M for minutes, colon, %S for seconds. And then we are going to assign all of this to a variable. Let's say local time, and local time will be a string. So let's print our local time, and the current time is January 23rd, 2021, about 3 p.m. Oh, and I almost forgot, you can also get the UTC time. That is the Coordinated Universal Time, if you know how that works. So if you need that, you would just use the GM time method for the UTC time, Coordinated Universal Time. Okay, next up we have the strp time function. And this function will parse a string representation of a time and or date and return a time object. So we need to pass in a string representing the date and or time, as well as a format string. So let's create a time string, and this variable is going to be a string representation of a date. Let's say 20th of April, 2020. And what we can do is take this string representation of a time and or date and parse it to a time object. So we're going to pass in our time string variable as well as a format string. So let's say I would like to parse the day, so that would be %d for day, then %b for name of the month, and then comma, %y for year. This function will create a time object, so let's assign that to a variable. Time object equals time.strp_time. We're passing in our string representation of a time or date, as well as a format string. And we can print our time object using a print statement. However, this is going to be in a form that is somewhat difficult to read, but you can see at least we have a time object with all of these keywords filled in with anything that we passed in via these format directives that we have. Now the next function is the ASCTime function, and this function accepts a time object or a tuple representation of a relative time. So this time let's create a time tuple, and we're going to follow this order. We can pass in up to 9 values. The first value is a year, so let's pass in perhaps 2020, a month, let's say 4, a day, how about 20, 4 hours, let's say 4, minutes, 20, and seconds, maybe 0. Let me just fix some of the spacing here. Okay, you can also pass in a numbered day of the week. I'm just going to say 0. I don't think it's really that important. A day of the year, 0, and -1 or 0 for daylight savings time. So we created a time tuple, and we can pass in a time object or a tuple representation of a time following this formula. So let's pass in our time tuple, and this will create a time string, a string representation of the time that we create. And let's print our time string. And we should have April 20th, about 4 in the morning, the year 2020. So that is ASC time. It will convert a tuple representation of a time and date or a time object and convert it to a readable string. Now another option is to use mktime, and mktime will take a tuple representation of a time or a time object and convert it to seconds since epoch. So April 20th of the year 2020 is about 1.5 billion seconds since our epoch date, and for me that was December 31st, the year 1969. So that is a few useful functions of the time module. If you would like a copy of this code, I will post all of this to the comment section down below. And well, yeah, that's the time module in Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain multi-threading in Python, so sit back, relax, and enjoy the show. Think of a thread as a flow of execution, like a river, and each thread can carry out its own separate order of instructions. If we use this process of multi-threading, we can have our program run different parts of its program at different times. They all run concurrently but not truly in parallel. That is a concept for later referred to as multiprocessing. So with threads, they each take a turn running to achieve concurrency. This is due to a notorious feature known as the GIL, the Global Interpreter Lock. Only one thread can be running at one time, but they can all take turns when one thread is idle. So this allows one thread to hold control of the Python interpreter at any one time. So they run concurrently but not truly in parallel, which is what we do with multiprocessing. Now, programs and tasks can be divided into two different categories. They can be CPU bound, that is a program or a task that spends most of its time waiting for internal events, such as a task that is CPU intensive. It is better to use multiprocessing for tasks that are CPU bound. Now, tasks that are I/O bound means that the program will spend most of its time waiting for external events, such as waiting for user input, or if you're doing activities like web scraping, you do a lot of sitting around. So with I/O bound tasks, it's better to use multi-threading because we can have multiple threads running concurrently, but not truly in parallel like what we do with multiprocessing. After importing the threading module, we can count the number of threads that are currently running in the background. Whenever we run a program, we have one thread that is running that is in charge of executing our program, and we can print the active count of threads running in our program using the active count function of the threading module. So this will print 1. We have one thread that is running, and we can print a list of all of the threads that are running by using the enumerate function. So the one thread that is in charge of running our program is referred to as the main thread. By using this concept of multi-threading, we can have more than one thread running concurrently, not truly in parallel. All the threads will take turns while one of them is idle. So we can have more than one thread running, more than just the main thread, which is in charge of running the main body of our program. So while our main thread is in charge of running the main body of our program, we can have another thread that's in charge of a separate part of it, maybe like a countdown timer or something. So one good example, take that quiz game that we made some number of videos ago. While we were waiting for user input, which is a I/O bound task, we could have had a countdown timer going, like you only have so many seconds to answer this question. We could have had one thread in charge of waiting for user input and another thread in charge of the countdown timer. So that's an example of multi-threading. We had two threads running concurrently. And what we'll be doing in this video is creating a program that involves multi-threading. We can have different threads in charge of different parts of our program, and they can all run concurrently. They'll all take turns while one of them is idle. So let's say that we're running late for school or work in the morning, and we have 3 different tasks that we need to complete before we can leave for school or work. So think of 3 different things you do in the morning, such as maybe eat breakfast. Some people drink coffee or maybe a beverage of your choice, so drink coffee. And some people like me, they like to do their homework last minute, so I'll say study before I leave for work or school in the morning. So what we'll do in each of these functions should take some amount of time to complete. So we can have our main thread sleep for a given number of seconds using the sleep function, time.sleep. And let's say that in order for me to eat breakfast, this task will take me 3 seconds. Let's just pretend that instead of minutes, this will be in seconds. So drink coffee will take me 4 seconds, and study will take me 5 seconds. Then when we finish sleeping, let's print a confirmation message. Let's say you eat breakfast, as in you finish eating breakfast. With drink coffee, you drank coffee. And with study, you finish studying. Now, each of these tasks are I/O bound. They're going to be spending a lot of time just waiting around for external events. They're waiting for the sleep function to expire before they can finish their task. So we're going to have all of these 3 functions run on our main thread, and we'll see how long it takes for us to complete our morning ritual, these 3 tasks. So let's call these 3 functions within our main thread. So let's call the eat breakfast function first, followed by drink coffee, and then study in that order. So this program is going to take approximately, 12 seconds to complete. So there's going to be a pause for a second. You eat breakfast, then followed by you drank coffee, and then study. You finish studying. So this program took about 12 seconds overall. So if this were realistic, what we would have done is we would sit down and eat breakfast for 3 minutes, well, 3 seconds in this case, and then once we finish eating breakfast, only then are we allowed to drink our coffee, and once we finish our coffee, only then can we study. So we completed these tasks sequentially and not concurrently. For us to move down to the next function, we need to complete the previous functions because we're doing this in order. But realistically, us human beings, we would probably eat breakfast, drink coffee, and study all together because we can multitask and we can complete these 3 functions in less time. And that's kind of the same process as multi-threading. We can have these 3 separate functions running concurrently as if we're multitasking. We're eating breakfast, drinking coffee, and studying all at once. Now, currently we have one thread that is in charge of these 3 separate functions. What we could do is that we can create 3 additional threads. Each thread will be in charge of each task, and then we'll have our main thread running in the background that will complete the rest of the program. So this is how to create an additional thread. Let's say that x equals threading dot thread. We need to pass in a target equals, and then the name of the function. So let's say thread x will be in charge of eating breakfast. And then you can pass in arguments too if your function has parameters by typing args, and then you pass in a tuple. So let's say you have one argument to pass in, you'll type your argument followed by a comma. But we don't have any arguments in this example, but you'll need to be sure to enter them in if you do have any. Okay, then to begin this thread, you type the name of the thread, in this case x, dot start. So we now have an additional thread, and this thread is in charge of eating breakfast. Now let's create another thread to drink coffee, and we'll call this y. And the target will be drink coffee. And lastly, we have a thread in charge of studying, and this will be z. And the target is our study function. Okay, now let's see how long it takes for us to complete our program. Oh, and be sure to comment out these function calls within the main thread because we don't want the main thread in charge of those anymore. Okay, now we can run the program. So we have 4 threads running this time. You eat breakfast, you drink coffee, you finish studying. So this program took approximately 5 seconds to finish. And the reason that this program took 5 seconds instead of 12 is because before, our main thread was in charge of running these tasks sequentially in order, but now since we have a thread dedicated to each task, we can run them all concurrently instead of sequentially, so that this program now took about 5 seconds to complete. And you may have noticed too that the ActiveCount function as well as the enumerate function were called before threads 1, 2, and 3 finished their respective tasks. That's because the main thread is not going to wait around for these 3 threads to complete. It has its own set of instructions to do, so it is no longer in charge of these 3 functions. The program is going to handle those 3 functions to our 3 threads, and our main thread is going to continue its own set of instructions. Its job is to print the active count as well as call the enumerate function, which it did, and it finished its tasks before threads 1, 2, and 3. Now, one trick that you can do too is that you can use the time module's performance counter function, and this function will return how long it takes our calling thread, as in our main thread, to finish its set of instructions. So our main thread is not in charge of executing these 3 functions. Our main thread is in charge of creating 3 additional threads and then calling the ActiveCount function and the enumerate function, as well as the performance counter function. So our main thread will take approximately 0.075 seconds to complete, and our 3 threads are still running in the background. Our main thread's job, its order of instructions, is to create 3 additional threads and then immediately print whatever is returned via the ActiveCount function, enumerate, and then your performance counter. So our main thread says that it finished its tasks in about 0.07 seconds, but threads 1 through 3 were still trying to catch up. That's why the main thread finished before our 3 additional threads, and once all active threads have completed their tasks, then your program will finish and exit. There's also this concept called thread synchronization, we can have a calling thread, in this case our main thread, wait around for another thread to finish before it can move on with its own instruction set. So let's say we would like our main thread to wait around for thread 1, also known as X. So we're going to use the join function of thread X. And now our main thread has to wait around for thread X, also known as thread 1, to finish before it can move on with its instruction set. So let's do the same with Y and Z. So now our main thread, before it can move on with the rest of the program, has to wait for all of these threads to synchronize and join, and then, and only then, can it move on with the rest of its own instruction set. So this time, our program is going to look a little something like this. You eat breakfast, you drink coffee, you finish studying. So by the time we reach our active count, these threads are already joined and synchronized. They're no longer active. When we enumerate over our active threads, we only have our main thread, and our main thread completed in about 5.1 seconds this time because it did a lot of waiting around. It was waiting for threads X, Y, and Z to join and finish. In conclusion, a thread is a flow of execution, like a separate order of instructions that a program can follow. And when we run a program, we always have at least one thread running initially, and that is referred to as the main thread. However, if you have multiple threads using the concept of multi-threading, we can have multiple threads running concurrently, but not truly in parallel, which is what we'll cover during the video on multiprocessing. This is due to a feature known as the GIL, the Global Interpreter Lock, which allows only one thread to hold control of the Python interpreter at any one time. And tasks can be either CPU-bound or IO-bound. A CPU-bound task is a program or task that spends most of its time waiting for internal events, such as a task that is CPU-intensive, and IO-bound tasks spend most of their time waiting for external events, such as waiting around for user input or web scraping. With IO-bound tasks, it's better to use multi-threading. With CPU-bound tasks, it's better to use multiprocessing. Well, everybody, that is a quick overview of multi-threading. I will post all of this code to the comments section down below. And well, yeah, that's how to achieve multi-threading using Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain daemon threads in Python. So sit back, relax, and enjoy the show. Okay, so daemon threads, also pronounced as daemon threads. A daemon thread is a thread that runs in the background, and they are normally not important for your program in order to run. Your program will not wait for daemon threads to complete before exiting, whereas non-daemon threads, they cannot normally be killed. They will stay alive until their task is complete. So a few common uses of daemon threads would be background tasks, garbage collection, waiting for input, or other long-running processes. So here's an example of why daemon threads would be useful. Let's say that we'll have two threads. Our main thread will be in charge of waiting around for some user input. We'll ask, do you wish to exit? And in the background, we'll have a timer going that will display how long somebody is logged in. So let's create a function named timer. And what we'll do is just display how long somebody's logged in. So let's say we have a count variable. While true, we'll use the sleep function of the time module to sleep for approximately 1 second. Then we'll increment our count variable by 1, and we'll print a message. So let's say logged in for count seconds. And let's create a thread that will be in charge of this timer and run it in the background. So let's say x equals threading.thread. The target will be our function of timer, and we need to start this thread, x.start. So our thread x will be in charge of our timer and run it concurrently while we're waiting for some user input. Our main thread will be in charge of waiting for this user input. Do you wish to exit? Now, here's the issue of us using a non-daemon thread for a background task, such as a countdown timer. So our main thread is in charge of waiting around for some user input, and thread X, our additional thread, is in charge of running this countdown timer. So if I wish to exit this program, I'm just going to type Okay, and hit enter. Well, my background timer is still going, but my main thread is complete. So I would like to exit this program, but my program will not exit as long as there are non-daemon threads that are still alive. We cannot normally close this program unless we do like a brute force, close and exit of the program. So we can turn this thread of X into a daemon thread so that when we wish to exit the program, when there are no more non-daemon threads alive, and to change a thread to a daemon thread, it's actually fairly easy. When you create your thread, you can set this flag of daemon equal to true, and that's it. So when all non-daemon threads have finished their tasks, your program will complete and exit. But if there are daemon tasks running in the background, they will be killed automatically. So let's try this program again. So do you wish to exit? My program is going to continue running. My daemon thread is in charge of the timer, and it's going to continue running until all non-daemon threads have completed their tasks. So once I type OK, my program will finish running and my countdown timer will stop because all daemons are killed when your program has finished running. There's also two additional methods that you might be interested in. You can use the set daemon method of a thread, and you can set it to false or true if you would like to change a thread to a non-daemon or a daemon. However, if your thread is currently running, well, you cannot actually change it from a non-daemon thread to a daemon thread while it's currently running. So you would have to do that before you actually use the start function. And you can also check to see if a thread is a daemon or not by using the isDaemon method. This will return true or false. So everybody, in conclusion, a daemon thread is a thread that runs in the background and they're not important for your program in order to continue running. Your program will not wait for daemon threads to complete before exiting the program, whereas non-daemon threads cannot normally be killed. They will stay alive until their task is complete, and daemon threads are commonly used for background tasks, garbage collection, waiting around for input, or other long-running processes. So if you would like a copy of this code, I will post all of this to the comment section down below. But yeah, those are daemon threads in Python. Yo, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to explain multiprocessing in Python, so sit back, relax, and enjoy the show. What's up? Let's talk about multiprocessing. Multiprocessing is the act of running tasks in parallel on different CPU cores. It's different from multithreading, although it sounds similar, because with multithreading, we're limited to running one thread at a time because of the GIL that lock, which is used for threading. We can run threads concurrently, but not in parallel. However, with multiprocessing, we can create processes, and we can run each process in parallel on a different CPU cores. So with multiprocessing, it's better for tasks that are CPU bound, where you need heavy CPU usage, whereas multithreading, that is better for IO bound tasks where you do a lot of waiting around. So before we begin, I recommend these two imports, multiprocessing and time. Let's begin. Quick note, if you're running the Windows operating system, you'll probably need to add this line, if name is equal to main. So when we run a program, we have a main process that is running, and if we create a child process from that process, it's going to copy the module that we're currently working with, and that child process will create its own children processes, and it's going to be a problem. So we're going to add this line, if name is equal to main. So when we create a child process, it will copy our module, but it's not going to execute it. So let's create a main function, and a majority of our code is going to be within our main function. If you're running a different operating system, you probably don't have to do this, but if you're running Windows, you probably will. Now with multiprocessing is better for tasks or functions that are CPU bound where they require heavy CPU usage. Let's say that we have a function named counter, and we'll pass in a number to count up to, but the number we're going to pass in is a ridiculously large number like a billion. So let's create a function that will count from 0. So count equals 0, and while count is less than our number that we pass in, we will increment our counter by 1. So that is the function that we'll call with our processes that we create. Now within our main function, we'll create a process, and to do that, you'll need the multiprocessing module. So import process and CPU count, and we'll save this for a little bit later. To create a process, let's say we have process A. A equals process. This step is very similar to creating a thread. We have a target. Our target will be our function of counter. And if we have arguments, we will pass those in. So remember, with our arguments, we have to pass in a tuple. Since we only have one argument to pass in, to differentiate this from an expression, we have to add a comma at the end. So our number, let's say, is 1 billion. So that's a million, 10 million, 100 million, 1 billion. Let me just verify that. Okay, so that's 1 billion. We're going to count from 0 to a billion. And in order to start this process, my process, use the start function. And then I will use some process synchronization by using the join function. My main process is going to wait around for my child process of A to finish before continuing. And let's print our performance counter. So we'll print finished in, let's say, time.performance counter seconds. Okay, so let's see how long it'll take to count from 0 to a billion using one process. I fast forwarded this video, but it took my program 56.7 seconds to count from 0 to a billion, but we can speed this up by using multiprocessing. Let's create a second process named B. And I'm going to divide the amount of work in half, so each process will count to 500 million, half of a billion. So let's change A to B, and I'm going to group these start functions together, just so it's easier to read, and then B.join, just to synchronize everything. Okay, and then let's change 1 billion to 500 million for each. It's the same amount of work, but divided among workers. So that is 500 million. Let's see how well it runs this time. So it took my program about 40.3 seconds to finish counting from 0 to a billion, but I divided that task among different processes. Each of my two processes counted from 0 to 500 million this time. So this time, let's create 4 processes. So we have A, B, C, and D. And we'll need to start them. And I'm going to join them. Now, this might not actually speed it up for you, and I'll explain why later. It depends on the amount of CPU cores that you have. Okay, so, let's change this too. So, 250 million for each. Okay, see you in a couple seconds. Okay, welcome back. So, on my computer, when I ran 4 processes, and each was counting up to 250 million, I could finish my program in 27.3 seconds. Now, for me, if I created more processes than this, it would probably take longer, and here's why. So you can print the CPU count of your computer using this function of CPU count. So if I were to print whatever this function returns, I can get the count of the number of additional processes that I can run. For the time being, I'm just going to comment out this start function because I just want to print whatever this value is. So my CPU count on my computer is 4. So I can run 4 additional processes, but let's attempt to run 8 processes. So I'm going to copy all of these, and let's say that we have E, F, G, and H. And we will start all of those too. So give me a second just to start them. So A, B, C, D, E, F, G, H, and then I'm going to join all of them. E, F, G, and H. Okay, so let's run this now. Oh, and change the arguments too. I keep forgetting to do that. So let's say 125 for each. So 125 million times 8 is 1 billion. Okay, see you in a bit. Alright, welcome back. This time when I had 8 processes working, it actually took me longer than when I had 4 processes working. When I had 4 processes working, it took me about 27 seconds. This time it took 30 seconds when I had 8 processes working. That's because I had more processes than my CPU count. And that's partially because whenever you create a process, there's significant overhead with beginning and destroying a process. And if I can only run 4 processes on my computer at one time, well then I'm creating additional processes to no extra benefit. It's actually hindering the performance of the computer because I'm creating all of these additional processes when it really doesn't help me. In conclusion, multiprocessing is the concept of running tasks in parallel on different CPU cores. It's similar but different from multithreading because with multithreading, we can run tasks concurrently, but they're all taking turns because of the GIL. With multiprocessing, we can run all of these different tasks together in parallel. Multiprocessing is better for CPU-bound tasks, where a task has heavy CPU usage, and multithreading is better for IO-bound tasks, tasks that involve a lot of waiting around. So that's multiprocessing. If you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, that is how multiprocessing works in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video we're going to be creating our very first graphical user interface in Python, so sit back, relax, and enjoy the show. Welcome one and all. Today we'll be creating our very first graphical user interface in Python, also known as a GUI for short. We're going to be using the tkinter GUI, which is a module that is included with Python. Our first step in order to use tkinter is to import this module so that we can begin using it. Our first line of code will be from tkinter import asterisk. This will import everything related to the tkinter module. And with this import, we can now use all of the GUI features that this module has to offer. Now, there is one important distinction that we need to make. We need to discuss the differences between windows and widgets. Here's a few quick definitions that I definitely did not copy from the internet. Widgets are GUI elements such as buttons, text boxes, labels, images, you name it. And windows, they serve as a container to hold or contain these widgets. For this topic, we'll be creating and customizing our own window, and in future topics, we'll be exploring different widgets that are available to us. So let's begin by creating a simple window, and we should give our window a unique name, such as window. That's pretty creative, and in order to instantiate this window, we're going to follow this window name with equals tk. Make sure you get the capitalization right. This is a uppercase T, and a set of parentheses to serve as the constructor. What this will do, and I'm just going to add a comment, is instantiate an instance of a window for us. And when we compile and run this, nothing appears to happen. That's because we only instantiated our window and we're not actually displaying it. In order to display our window, we're going to follow this with the name of the window dot main loop, and this will display our window. And this is our first graphical user interface, and we'll be adding widgets to this window. So I'm going to add a comment that this will place window on computer screen, and it will also listen for events, but we'll get to that in future videos. Now what we'll be doing is customizing the appearance of this window. Let's begin by changing the size, and we can do that with the geometry function. So we're going to first begin by typing the name of our window, which is window, follow this by using the geometry function, and we pass in a width and a height, but make sure this is within quotes, and set this to whatever width and height that you want. So if I want 420 by 420, that would be 420 x 420. And the size of our window is now the size that we set with the geometry function. Now take a look at the top left of this window. We have this feather icon as well as a title of TK. That's kind of lame, so let's change that. Let's first change the window title, and there is a function to do that. So we type in the name of our window, window dot title function, and we can pass in a new title that we want to set. And I will set the title to be maybe bro code first GUI program. That'll work. And we now changed the title of this window, and it says Bro Code First GUI Program. The next thing that we can do, although not necessary, is that we can change the icon of our window bar at the top. I would like to replace this feather icon with an image of my choosing. Here's my desktop, don't mind all of the clutter, and I would like to use this image of the logo for my channel and set this as the icon for my window. So what I'm going to do is copy this, and then go to my project folder, and then paste it. Click OK. And I now have this image within my project folder, but it's in a format that we cannot use currently. We need to convert this to what's called a photo image. That is a format that tkinter can use. So we'll need to convert our image to a photo image. So do that anywhere within the window between window equals tk and window.main loop. Right here is good, I suppose. We're going to create a photo image from this image, and this is a PNG file, but yours might be something different. So let's give our photo image a unique name, like maybe icon. And in order to create a photo image, we'll follow this with equals photo image. And within the constructor of our photo image, there's an option for file. We can either list the file name or the file path if it's somewhere else on your computer. Since this image is within my same project folder, I only have to list the file name. And this is called logo.png. And this is probably going to be named something else for you though. So we now have this photo image called icon that we can use. And I need to set the icon of my window to this icon. And luckily there is a function to take care of that for us. Type in the name of the window, which is window, dot, and we're going to use the icon photo function. There are two arguments. The first we're going to set to true. And the second is the photo image that we want to use, and this photo image is called icon. So we're going to pass this photo image as an argument to this function of icon photo. And now when we compile and run this, the image that we wanted to use is now set for the top left icon of this window bar. However, it loses a lot of the quality since the dimensions are so small, but you can still tell that it's my logo though. So that's how to replace the icon of your window bar in the top left corner. Now let's change the background color of this window, and one way in which we can do that is to use the config function. You can use the config function anytime that you want to make any changes to this window. So let's change the background color here, and there is an option called background. And we can set this equal to either a color name or a hexadecimal value. Let's begin with just some color names. Let's say that I want the background color to be black. I'll just type in the word black here, and this will change the background color of my window to black. Alternatively, you can set a hex value as the color. So if you were to look up or Google hex color picker, you can select whatever color you want. Let's say that I want a sky blue color like this. Well, this is the hex value. I'm going to copy this value and then paste it within the option for my background. Make sure you have this hashtag as well, because that represents that this is a hex value. So now the background color is that sky blue color that I picked. Well, everybody, that's the basics of creating a window in Python, and in future videos we're going to be exploring different widgets that we can add to this window that have some functionality. So if you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to create your very first GUI in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can create labels in Python, so sit back, relax, and enjoy the show. What is a label? Well, I'm glad you asked that question. It's an area widget that holds text and or an image within a window. So to begin, we'll need to create a window to act as a container to hold this label. We can create a window with window equals tk followed by window.main loop, and this will give us a window in which we can add a label to. Now let's give our label a unique name, such as label, and in order to instantiate a label, we'll follow this label name with equals label with a capital L and a set of parentheses. The parentheses are acting as the constructor for this widget, our label, and we can pass in arguments into these parentheses. The first argument that we're going to pass in is a master, the container. For this label, we're going to pass in the name of our window because our window is acting as the container. With widgets in Python, we can delimitate the arguments that we're passing in with a comma, and there are options available to us. Options are keyword arguments that we can pass in to the constructor for this widget. One option available to us is text, and we can set the text of this label equal to a string that we set. So let's say that we want this label to say, hello world. Well, we're going to pass in this option, text, and it's a keyword argument. So if we were to do this, we're going to set the text of the label, but this label currently doesn't appear within our window. What gives, bro? I thought you knew how to code. Hold up, wait a minute. There's one more thing that we need to do. So we're going to actually add this label to the window now. We set the master of the label to be our window, but now we actually have to add it as step 2. One way in which we can do that is to use a pack function of our label. So follow label equals label and pass in all of your arguments, and then follow this with the name of the label dot pack. So with the pack option, by default, this will place our widget in the top center of our window. Another way in which we can add a label to a container or window is to use the place function, and we can set some coordinates of where we want this label or other widget to appear within the window. If we want this to appear in the top left corner, we can set x to equal 0 and y to equal 0, and these are options available to us too that we can pass in. So this place function will place our label at some position or some set of coordinates within the window, and with x equals 0 and y equals 0, that will place our widget in the top left corner of the window. And if I were to change these to, let's say, x equals 100 and y equals 100, well, this is going to be placed down by 100 pixels and to the right by 100 pixels. So you can use pack or place. There's a few others like grid, but they're a little more complex, so we'll get to that in a future video. For the time being, I'm going to use the pack function of the label and turn this place function into a comment, label.pack. All right, now how can we customize this label? We can pass in different options when we instantiate this label. Let's change the font, and that's another option. We can change the font with font equals, and then we can pass in a font. Let's begin with a font family. I will say maybe Arial, a size, perhaps 40, and then a style if you so choose, like bold. There's also italic and underline, but this will work just fine then. So this will change the font of the text of our label, and it says hello world still. Now let's change the foreground color. So that is another option. The foreground is the font color, and the option is FG for foreground. It's short for foreground. Foreground equals, we can state a color name, such as green, and our text should now be green. You can select something more specific by passing in a hex value. So a custom color that I like is hashtag 00FF00. This is bright green. You can always look up what different hex values are. And we can also change the background color too. That is BG, short for background color. And we can pass in a color name or a hex value. I'm just going to set this to black, just to demonstrate that we can pass in both either hex values or color names. And what we have is green text on a black background. And this is the limits of our label within the window, because when we expand this window, the label is still going to stay the same size. If we were to change the text within the label, our label is only going to take up the room that it needs. And you can see that our label is now smaller. Now we have all of these arguments within our constructor, and it's getting a little bit difficult to actually read. So I'm going to separate each of these arguments line by line, just so that this is more organized, but it'll work just the same as it did before. Now, how do we add a border around our label? One, we can set the border style with the relief option, and one border that I like is raised. But right now, the border width is 1, so it's a little difficult for us to actually see the border. Let's increase the border width with the option BD, and I'll set this equal to maybe 10. So this border is now more visible. Another relief, which is the border style, is sunken, and this will give our label a sunken appearance, but I think I'll change this back to raised. We can also add some padding around the text, between the text and the border. We can pad X and pad Y. Pad X will add some padding, some space between the X-axis of our text between the border. So let's set this to maybe 20, and we now have 20 pixels worth of space between the text and the border. Let's also pad Y. This will add some space above and below our text, between the text and the border. Now, how do we add an image to a label? We first need to create what's called a photo image, and we will create this within the lines of window equals tk and window.main loop. And let's give this photo image a unique name, like photo. And in order to create a photo image, we're going to follow this with photo equals photo image. And within the constructor of our photo image, there's an option called file, and we can list a file path or a file name. Right now on my desktop, there is an image that I want to use, and I need to convert this to a photo image. Here's my desktop, and this is an image that I want to use to add to my label. I need to get the file path, and I can get that by going to Properties, then underneath Location, I can copy this location address and paste it within the quotes for file. And then I need to add the image name, and this is person.png. And with these backslashes, these need to be double backslashes because that is the escape character for a backslash. But what would be a better option is to add this image to my project folder that contains the Python file that I'm working with. So in place of listing the entire file path, I'm going to copy the image that I want to use, go to my project folder, and then paste it. And I no longer need this entire file path. I can just list the image name that I have. And now what we need to do is add this photo to the label, and there's an option to do so. That is the image option, and we'll place this within the constructor for the label. We're going to set image equal to the photo image that we have, and our photo image is called photo. This will add our photo image to our label, or other widget depending on what we're working with. So we have our image, but it replaced all of the text that we had for this label. How do we add both text and an image to a window? Well, we can follow this with the compound option. We can set a direction of where we want this image to be placed relative to the text that we have. So I'm going to set compound equal to bottom so that the image appears on the bottom or underneath our text. So we can both have text and an image. Or if I want this to be in a different location, I could set this to maybe top, left, or right. If I were to set this to top, we have our image on top of our text. And one thing to know about labels and many other widgets in Python is that the size of the widget will actually increase to accommodate the size of all the components that's contained within. If I were to give the text a longer string of characters, such as bro, do you even code, then the width of our label is actually going to expand to accommodate the size of the longer string of text that we have. So that's the basics of labels, everyone. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of labels in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create buttons in Python. So sit back, relax, and enjoy the show. Buttons. You click them, and then they do stuff. That's pretty much it. So this is how to create a button in Python. We'll need a window equals tk, followed by window.main loop. Let's call our button just button. And in order to create this, we'll follow this with equals button. And within the constructor for this button, we're going to list what we want to add this button to. What is the master? The master is the window. And in order to display this button, we're going to follow this with button.pack. And we should have a small rectangular button within our window, but it doesn't display any text, nor does it do anything. So let's add some text, and there is an option to do that. Within the constructor, we're going to list the option for text and set this to whatever text you want to display. Let's say click me, and then when we run this, our button now says the text that we set, and it says click me. However, it currently doesn't do anything though. We need to set a command. That is another option. Command equals, and we list a function name. This is what's known as a callback. So let's create a function called click. And then outside of the window, let's define what our click function does. def click, and let's print a message. You clicked the button. Now, with the command, we're going to list the function name without the parentheses. So make sure you're writing it as this and not that. This is what's known as a callback. So when we click on this button, it's going to perform our callback and perform whatever is within our function click. Just like that. Let's customize the appearance of this button. I'm going to change the font. That is another option, font equals. And let's pick a professional font such as Comic Sans. It's very professional. And I'll set a size of 30. And now you can actually read what's on this button. It's large enough. Let's set the foreground color. That is the font color, FG. You can place a color name or a hex value here. I'll pick green, that is 00FF00. And our text should now be green, which it is. Let's also change the background color. That is BG. I will pick the color name of black. And now we have green text on a black background. Notice that when I click on this button or hold my mouse button down, the color scheme has changed. That's because there is a different active foreground and active background. And we can change those too, so that this won't flash every time you click on the button. So let's change the active foreground and active background. Those are other options, active foreground, and I'll set this to the same color as my foreground, which is green. So the text color is going to stay the same, and I'll also change the active background. And I will also set this to black to match my background. And then this should no longer flash when we click on our button. If you need to disable somebody from clicking on this button, there's an option to do so, and that option is the state option. And normally this is active, but you can set this to disabled, and we can no longer click on this button. And you can see that the color scheme has changed too. It's all grayed out and whatnot. So I'm going to replace this back with active because we still have a few more things to do. Now, how do we add an image to a button? There is an image option, and we set this equal to a photo image. But first, we need to create a photo image. I have this photo of a like button, a thumbs up that I want to use. I need to create a photo image from this image file. So within the window, let's call this photo image just photo. Photo equals photo image. Then I'm going to list the file path or the file name. Since this image is within my same project folder, I only have to list the file name, and this is called like.png, but if you use your own image, it's probably going to be named something else. Then I need to set the image equal to my photo image, which I named photo, but the photo replaces the text on this button, but it still works the same. So we would like to display some text as well as our image. We need to use the compound option. And we list a direction. We can list top, bottom, left, right. We want this image to be on the perhaps bottom. So let's list the bottom. And now when we run this, we have our text as well as our image. And if we changed compound to a different direction like top, then the image is going to be displayed on the top relative to the text. What if we wanted to count the amount of times that we clicked this button? We could create a variable called count, and we'll set this equal to 0. But in order for us to access this count variable within the function of click, we're going to list count as global, so that this is a global variable. Every time we click this button, let's increment our variable count by 1 by saying count plus equals 1, and then we will print whatever the value of count is. So within a print statement, we'll just say count. Now, when we click on this button, we have access to our count variable that's outside of this function, and every time we click on this button, it's going to increase our count variable by 1. Well, everybody, that's the basics of creating buttons in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of buttons in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a simple entry box in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, my fellow bros, in this video we're going to be discussing the entry widget. This is a text box that accepts a single line of user input. As always, we'll need a window. Window equals tk followed by window.